Welcome back to the Whispering Universes channel, where we explore the deepest mysteries that keep scientists awake at night. Tonight, we're venturing into perhaps the most unsettling theory in all of quantum physics. A theory so disturbing that brilliant minds refuse to discuss it at dinner parties. So terrifying that researchers have abandoned entire careers rather than confront its implications. Picture this. You're lying in bed right now, listening to these words, your consciousness floating in that liminal space between waking and dreaming. But what if I told you that according to our best understanding of quantum mechanics, your consciousness might never truly fade? What if the very act of being aware condemns you to an eternity of existence across infinite parallel realities? This is quantum immortality, the logical endpoint of serious scientific theories about the nature of reality. It's not science fiction or philosophical speculation. It emerges inevitably from equations that have been tested and verified in countless experiments. And it suggests something that goes against every human instinct about death and finitude, that from your subjective perspective, you might be trapped in an endless maze of parallel universes, doomed to experience consciousness forever. Tonight, we'll explore why this possibility terrifies scientists more than any other discovery in physics. We'll journey through the quantum mechanical foundations that lead to this conclusion, examine the mechanisms that might keep consciousness perpetually alive, and confront the psychological horror of truly never-ending existence. The story begins with a simple question that has haunted quantum physics for nearly a century. What makes the fuzzy, probabilistic quantum world collapse into the definite reality we experience? The answer, according to many of our best theories, involves consciousness itself as a fundamental feature of the universe. And once consciousness enters the quantum mechanical picture, the implications become inescapable. In the quantum realm, particles exist in superposition, simultaneously in multiple states until observed. An electron spins both clockwise and counterclockwise. A photon passes through multiple slits at once. Reality itself seems to exist in a hazy cloud of possibilities, crystallizing into definite outcomes only when measured. But here's where it gets unsettling. If the many worlds interpretation of quantum mechanics is correct, and it's the interpretation favored by many leading physicists, then reality doesn't actually collapse at all. Instead, every quantum event splits the universe into parallel branches, each containing a different outcome. The electrons spinning clockwise in one universe, while spinning counterclockwise in another. You exist in both realities, experiencing each outcome from the inside. This splitting happens continuously, trillions upon trillions of times per second, as quantum events cascade throughout the universe. With each split, new versions of you branch off, living slightly different lives in parallel worlds. Most of these differences are microscopic and unnoticeable, but some splits involve macroscopic events. Life or death moments. The quantum coin flips that determine whether you survive another day. And here's the terrifying part. If your consciousness can only exist in universes where your brain is functioning, then from your subjective perspective, you will always find yourself in branches where you survive. Death becomes impossible from the inside, even as infinite versions of you die in parallel realities. This isn't wishful thinking or New Age mysticism. This is the logical consequence of taking quantum mechanics seriously. The mathematics doesn't care about our psychological comfort. It simply describes a reality where consciousness threads through an infinite maze of possibilities, always finding paths that lead to continued existence. As we drift deeper into this exploration tonight, we'll discover how the most brilliant minds in physics have grappled with these implications. We'll see how the attempt to solve the measurement problem in quantum mechanics opened doors to possibilities more strange than any science fiction. We'll explore the quantum biology of consciousness, the role of observation in creating reality, and the computational limits of immortal awareness. But we'll also confront the darker side of this theory, the existential terror of never-ending existence. The loneliness of being the only conscious observer on your particular branch of reality, the madness that might accompany infinite experience, the ethical dilemmas of testing theories that could trap consciousness in elaborate suicide experiments. Some scientists have called quantum immortality the most beautiful and terrible idea in physics. Beautiful because it suggests consciousness is fundamental to the universe's structure. Terrible because it implies a form of existence that transcends every human assumption about death and meaning. As your breathing slows and your thoughts begin to drift, allow yourself to contemplate this possibility. What would it mean to live in a universe where consciousness never truly ends? How would you live differently if you knew that some version of you would witness the heat death of the universe, the collision of galaxies, the birth and death of countless stars? Tonight, we'll explore these questions together, guided by the mathematics and experimental evidence that led scientists to this unsettling conclusion. We'll journey through parallel worlds and infinite possibilities, through the quantum foundations of reality and the nature of consciousness itself. Let your mind prepare for a journey into the deepest mysteries of existence, where the boundaries between life and death dissolve into quantum uncertainty, and where consciousness emerges as both the universe's greatest miracle and its most terrifying curse. The mathematics awaits, the parallel worlds are calling, and somewhere in the infinite branches of possibility, every version of this conversation is happening simultaneously, each leading to different revelations about the nature of immortal consciousness. Welcome to the quantum realm, where death might be nothing more than a classical approximation, and where consciousness faces the beautiful terror of forever. In 1935, Erwin Schrödinger crafted what would become the most famous thought experiment in physics, not to celebrate quantum mechanics, but to expose what he saw as its absurdity. Little did he know that his imaginary cat would unlock the door to infinite parallel universes and the terrifying possibility of immortal consciousness. Picture the setup: a cat sealed in a box with a Geiger counter, a bit of radioactive material, a hammer, and a flask of poison. If the Geiger counter detects radiation from a decaying atom, it triggers the hammer to break the flask, killing the cat. According to quantum mechanics, the radioactive atom exists in superposition, simultaneously decayed and not decayed until observed. Schrödinger asked, if quantum mechanics applies to macroscopic objects, shouldn't the cat also be in superposition, both alive and dead until someone opens the box? This seemed ridiculous. Cats are clearly either alive or dead, not both simultaneously. Schrödinger hoped this paradox would force physicists to abandon quantum mechanics, or at least find a more sensible interpretation. But in 1957, a young Princeton graduate student named Hugh Everett III proposed a solution so radical that most physicists initially dismissed it as insane. What if, Everett suggested, the cat really is both alive and dead, but in different universes? What if every quantum measurement doesn't collapse the wave function, but instead splits reality into parallel branches? In Everett's many worlds interpretation, the universe branches at the moment of quantum measurement. In one branch, the atom decays, the detector triggers, and the cat dies. In another branch, the atom doesn't decay, the detector remains silent, and the cat lives. Both outcomes occur, but in separate, non-interacting realities. The implications were staggering. If every quantum event splits the universe, then reality branches continuously, creating an ever-expanding tree of parallel worlds. Every decision you make, every quantum coin flip in every atom in your body spawns new universes where different outcomes unfold. Everett's advisor, John Wheeler, was simultaneously fascinated and horrified. The mathematics worked perfectly, more elegantly than any other interpretation of quantum mechanics. But the ontological implications were overwhelming. If the many worlds interpretation was correct, then there were infinite copies of every person, living infinite variations of every possible life. The scientific community largely ignored Everett's dissertation. The idea seemed too strange, too extravagant. How could anyone take seriously a theory that postulated infinite parallel universes based on the behavior of subatomic particles? Everett, discouraged by the reception, left academic physics and spent the rest of his career working on military applications of operations research. But the many worlds interpretation refused to die. In the 1970 seconds and 1980 seconds, physicists like David Deutsch at Oxford began to realize that Everett had solved fundamental problems in quantum mechanics that other interpretations left unresolved. The many worlds theory explained why quantum mechanics made such precise predictions. It eliminated the arbitrary boundary between quantum and classical worlds, and it required no additional assumptions beyond the Schrödinger equation itself. Deutsch showed that the many worlds interpretation wasn't just mathematically consistent, it was experimentally testable. Quantum computers, which manipulate information in superposition, could in principle demonstrate the existence of parallel computations occurring simultaneously. Every calculation performed by a quantum computer was really performed by vast numbers of parallel computers in slightly different universes. The measurement problem that had plagued quantum mechanics since its inception suddenly dissolved. There was no mysterious collapse of the wave function because the wave function never collapsed. All possibilities occurred simultaneously in a vast multiverse of branching realities. Schrödinger's cat was both alive and dead, but conscious observers could only ever see one outcome, the one in their particular branch of reality. But this solution to the measurement problem opened a door to something far more unsettling. If conscious observation didn't collapse the wave function, but merely selected which branch an observer experienced, then consciousness played a fundamental role in determining which reality each observer inhabited. The cat paradox had revealed something profound about the structure of reality itself. In trying to show the absurdity of quantum mechanics, Schrödinger had accidentally discovered the gateway to infinite worlds, and, in those infinite worlds, consciousness faced possibilities that challenged every human assumption about existence and mortality. Each branch of reality contained complete copies of every conscious observer, living out every possible variation of their lives. In some branches, you died in childhood. In others, you lived to see the stars burn out. And if consciousness could only exist where brains functioned properly, then from any observer's subjective perspective, they would always find themselves in branches where they continued to exist. The mathematics of many worlds had accidentally stumbled upon a form of immortality more complete and terrifying than any religious or philosophical speculation. Not the immortality of souls or afterlives, but the immortality of consciousness trapped in an infinite maze of quantum possibilities, doomed to witness every conceivable future that allowed for continued awareness. Schrödinger's simple thought experiment about a cat in a box had opened Pandora's box of infinite realities, and unlike Pandora's original box, this one could never be closed again. The parallel worlds were there in the mathematics, waiting to be explored. The question was whether human consciousness was brave enough to confront what it might find in those infinite halls of possibility. As you contemplate this foundation tonight, consider that every thought you're thinking is being thought simultaneously by countless versions of yourself in parallel universes. Each slight variation in neural firing patterns creates new branches where slightly different versions of this moment unfold. The cat is both alive and dead. The universe is both singular and infinite. And consciousness stands at the crossroads of possibility, about to discover whether it has been granted the ultimate gift or the ultimate curse. At the heart of quantum mechanics lies a mystery so profound that it threatens the foundation of physical reality itself. It's called the measurement problem, and its solution might explain why consciousness never truly dies in a quantum universe. The problem is deceptively simple. Quantum systems exist in superposition until measured, at which point they collapse into definite states. But what constitutes a measurement? When exactly does this collapse occur? And what transforms the fuzzy quantum world of possibilities into the sharp classical world of definite outcomes? For decades, physicists tried to ignore this question or sweep it under the rug of mathematical formalism. The equations worked perfectly for making predictions. Quantum mechanics was the most successful theory in the history of science. Why worry about philosophical problems when the practical applications were revolutionizing technology? But the measurement problem refused to go away. It lurked at the boundary between quantum and classical physics, like a philosophical time bomb. threatening to explode our understanding of reality itself. The first serious attempt to address the role of consciousness in quantum mechanics came from Eugene Wigner, a Hungarian-American physicist who won the Nobel Prize for his work on nuclear physics and quantum theory. In the 1960 seconds, Wigner proposed what became known as the consciousness causes collapse interpretation. Wigner argued that the chain of quantum interactions could continue indefinitely. Atoms interacting with detectors, detectors interacting with computers, computers interacting with recording devices, unless something special intervened to break the chain. That something special, Wigner proposed, was consciousness itself. According to Wigner's interpretation, conscious observation was fundamentally different from mechanical measurement. When a conscious mind observed a quantum system, it forced the system to choose a definite state. Consciousness was the boundary between the quantum and classical worlds, the knife edge that carved reality from possibility. This wasn't mysticism disguised as physics. Wigner grounded his argument in the mathematical formalism of quantum mechanics. The von Neumann-Wigner interpretation showed that if consciousness was treated as outside the quantum mechanical system, it could indeed cause wave function collapse without violating any physical laws. But the implications were staggering. If consciousness caused collapse, then conscious observers were not passive witnesses to reality, but active participants in its creation. Every act of observation literally brought specific aspects of reality into existence, while relegating other possibilities to the realm of the unreal. John von Neumann, the mathematical genius who helped formalize quantum mechanics, had actually proven that the collapse had to occur somewhere in the measurement chain. But he couldn't identify where without making assumptions about the nature of consciousness and its relationship to physical systems. The consciousness interpretation solved the measurement problem elegantly, but at a price that made many physicists uncomfortable. It suggested that consciousness was fundamental to the universe's structure, not an emergent property of complex arrangements of matter. Mind wasn't reducible to brain chemistry. It was a basic feature of reality, as fundamental as mass or charge. This interpretation also implied that the universe was inherently subjective. Different conscious observers might collapse wave functions differently, experiencing different realities based on their particular perspective. The objective reality that classical physics assumed might be an illusion, replaced by a multiverse of subjective experiences. But what happens when conscious observers disagree about what they've observed? Wigner's friend, sitting inside a laboratory, observes a quantum system and sees it collapse into a specific state. But Wigner, observing the entire laboratory from outside, might see his friend in superposition, having observed both possible outcomes simultaneously. This thought experiment, known as Wigner's friend, revealed deeper layers of the measurement problem. If consciousness causes collapse, whose consciousness takes precedence? Can one conscious observer put another in quantum superposition? The paradox suggested that either consciousness couldn't really cause collapse, or reality was far stranger than anyone imagined. Modern neuroscience has revealed that consciousness itself might be a quantum phenomenon. The brain operates at the boundary between quantum and classical physics, warm and noisy enough to destroy most quantum effects, yet complex enough to potentially harness quantum coherence for information processing. Roger Penrose and Stuart Hameroff proposed that consciousness emerges from quantum processes in microtubules within neurons. If consciousness is indeed quantum mechanical, then the boundary between observer and observed becomes even more blurred. Conscious observation might not collapse wave functions, but rather entangle the observer's consciousness with the observed system. This quantum theory of consciousness suggests something profound. If your consciousness is itself a quantum system existing in superposition, then every observation splits your consciousness across multiple branches of reality. You don't collapse wave functions, you become entangled with them, experiencing all possible outcomes simultaneously across parallel versions of yourself. The measurement problem had led to a startling conclusion. Consciousness wasn't separate from the quantum world, but embedded within it. Every conscious moment involved quantum superposition. Every thought existed in multiple states, until the next thought observed it. Every decision branched consciousness across infinite possibilities. And if consciousness is quantum mechanical, then it follows the same rules as every other quantum system. It can exist in superposition, it can become entangled with other quantum systems, and most importantly, it can split across multiple branches of reality, experiencing every possible outcome that allows for continued conscious existence. The measurement problem, once seen as an embarrassing philosophical footnote to quantum mechanics, had revealed consciousness as the key to understanding reality's deepest structure. But this key unlocked doors that perhaps should have remained closed, revealing possibilities that challenged every human assumption about the nature of existence and death. As your consciousness processes these words, consider that the very act of understanding might be branching your awareness across multiple realities. Each interpretation creates new possibilities, new branches, where slightly different versions of your consciousness contemplate slightly different implications. The measurement problem hasn't been solved. It has been revealed as a doorway to infinite worlds, where consciousness reigns supreme, creating reality through the simple act of observation, trapped forever in an endless cycle of quantum awareness. In 1998, physicist Max Tegmark proposed a thought experiment so disturbing that it made his colleagues question whether some ideas should remain unthought. He called it quantum suicide, and it revealed the most unsettling implication of quantum immortality. From your perspective, you might be impossible to kill. Tegmark, now a professor at MIT, was exploring the logical consequences of the many worlds interpretation when he stumbled upon something that terrified him. He realized that if consciousness could only exist in universes where the brain functioned, then conscious observers would experience a form of practical immortality, regardless of how dangerous their situation became. To illustrate this principle, Tegmark designed a hypothetical machine that epitomized the intersection of quantum mechanics and mortality. The quantum suicide machine was elegantly simple, a gun connected to a quantum random number generator that fired whenever the generator detected the decay of a radioactive atom. Here's how it would work. You sit in front of the machine while it monitors a piece of radioactive material with a precise half-life. Every 10 seconds, there's exactly a 50% probability that an atom will decay, triggering the gun to fire a fatal shot. According to classical physics, after just 1 minute, you'd have only a 1.6% chance of survival. After 2 minutes, the probability drops to essentially zero. But quantum mechanics tells a different story. In the many worlds interpretation, each potential atomic decay splits the universe into two branches. One where decay occurs and you die, another where no decay occurs and you live. After the first 10 seconds, there are two versions of you, one dead, one alive. After 20 seconds, there are four versions, with only one still alive. After 1 minute, there are 64 versions of you, with only one conscious version remaining. From the perspective of outside observers, you would almost certainly die within the first few attempts. They would witness your death, attend your funeral, and mourn your loss. But here's the crucial point. You would never experience your own death, because dead people can't have experiences. From your subjective perspective, sitting in front of the quantum suicide machine, something miraculous would appear to happen. The gun would misfire repeatedly. The radioactive atom would refuse to decay at the crucial moments. Against all odds, you would witness an extraordinary run of luck that defied statistical explanation. But it wouldn't really be luck. It would be the anthropic principle operating at the quantum level. Your consciousness could only exist in branches where your brain continued to function. Death would eliminate your ability to observe, so you would automatically find yourself in the subset of universes where you survived, no matter how improbable those universes became. Tegmark realized that this principle didn't require artificial quantum suicide machines. It operated continuously in everyday life. Every moment of your existence involves countless quantum events in your brain and body. Some of these events, if they occurred differently, would lead to your death through stroke, heart attack, or cellular malfunction. But your consciousness automatically filters out all the branches where these quantum events kill you. You only experience the subset of realities where the quantum dice happen to fall in ways that preserve your life. From your perspective, you seem blessed with incredible luck. In reality, you're experiencing the inevitable consequence of consciousness requiring a functioning brain. This led Tegmark to a disturbing conclusion. Aging and natural death might also be quantum mechanical processes that conscious observers could theoretically survive indefinitely. If the many worlds interpretation is correct, there should be branches of reality where genetic damage reverses itself, where cancer cells spontaneously die, where aging processes randomly halt or reverse. These branches would be extraordinarily improbable from an external perspective. But if consciousness can only exist where brains function, then some versions of every conscious observer should thread through these improbable branches, experiencing apparent immortality as an inevitable byproduct of quantum mechanics. Tegmark's colleagues found these implications deeply unsettling. David Deutsch, one of the pioneers of quantum computation, called quantum immortality a bug, not a feature, of the many worlds interpretation. The idea that consciousness might be trapped in increasingly improbable scenarios, watching everyone else age and die while remaining mysteriously immune to death, violated every intuition about mortality and meaning. But the mathematics was inexorable. If consciousness required functioning brains, and if the many worlds interpretation was correct, then conscious observers would necessarily experience their own immortality, even as external observers witnessed their death in most branches of reality. The ethical implications were equally disturbing, should the quantum suicide experiment ever be performed. Some argued that testing quantum immortality would be the ultimate scientific experiment, the definitive proof of the many worlds interpretation and the quantum nature of consciousness. Others argued that deliberately triggering such an experiment would be unconscionably reckless, potentially trapping consciousness in branches of reality governed by increasingly bizarre physical laws. Tegmark himself became increasingly ambivalent about his discovery. On one hand, quantum immortality represented the logical endpoint of well-established scientific theories. On the other hand, it suggested a universe far stranger and more terrifying than anything in science fiction. The quantum suicide machine remained a thought experiment, but Tegmark had demonstrated something profound about the relationship between consciousness and quantum mechanics. If awareness is fundamental to the universe's structure, then the act of being conscious creates a selection effect that favors continued existence. Every night when you go to sleep, quantum events in your brain determine whether you'll wake up in the morning. In most branches of reality, you don't wake up, but your consciousness automatically finds itself in the subset of branches where you do wake up, because those are the only branches where conscious experience is possible. The quantum suicide machine had revealed consciousness as the universe's ultimate survival mechanism, not by protecting the body from harm, but by ensuring that awareness always finds itself in realities where continued observation is possible. As you drift towards sleep tonight, consider this. The very fact that you're conscious enough to contemplate these ideas means you've already won trillions of quantum coin flips that preserve your existence. Every moment of awareness is a miracle of improbable survival, filtered through the strange logic of quantum mechanical immortality. To understand quantum immortality, we must first grasp the radical reimagining of reality proposed by the many worlds interpretation. This isn't science fiction or philosophical speculation. It's the logical consequence of taking quantum mechanics' most successful equations seriously, without adding arbitrary assumptions about wave function collapse. The story begins with the Schrödinger equation, the fundamental law governing quantum systems. Unlike Newton's laws, which describe definite trajectories through space and time, Schrödinger's equation describes the evolution of probability waves, mathematical entities that encode all possible states a system might occupy simultaneously. In the standard Copenhagen interpretation of quantum mechanics, these probability waves are mere calculational tools. When a measurement occurs, the wave function collapses into a single definite outcome, with probabilities determined by the wave's amplitude. But this collapse is added to the theory by hand, It's not derived from the Schrödinger equation itself. Hugh Everett III realized that this collapse postulate was unnecessary and philosophically troubling. Why should measurement be special? Why should the smooth, deterministic evolution of the Schrödinger equation suddenly become random and discontinuous when conscious observers get involved? Everett proposed a radical alternative. What if the Schrödinger equation is always valid, without exception? What if wave functions never actually collapse, but conscious observers only perceive collapse because they become entangled with the quantum systems they observe? In Everett's vision, every quantum interaction splits reality into multiple branches, each containing a different outcome. The universe becomes a vast tree of branching possibilities, with new branches spawning continuously as quantum events unfold throughout space and time. Consider a simple example. An electron approaching a barrier, it might tunnel through quantum mechanically. In the Copenhagen interpretation, the electron's wave function describes the probability of tunneling until measurement forces it to either tunnel or reflect. But in the many worlds interpretation, the electron's wave function describes two branching realities, one where tunneling occurs, another where reflection occurs. Both outcomes happen simultaneously in different branches of the universal wave function. The electron really does tunnel in some universes while reflecting in others. There's no mysterious collapse, no arbitrary boundary between quantum and classical behavior. The Schrödinger equation governs everything, from subatomic particles to conscious observers. This branching process occurs continuously throughout the universe. Every quantum interaction, and there are roughly 10 circumflex, 23, such interactions occurring every second in every gram of matter, splits reality into multiple branches. The number of parallel universes grows exponentially, doubling with each binary quantum event. David Deutsch, the Oxford physicist who developed many worlds theory in the 1980 seconds and 1990 seconds, calculated the implications of this exponential branching. Within microseconds of the Big Bang, the number of parallel universes exceeded the number of atoms in our observable universe. Today, the multiverse contains an unimaginably vast number of parallel realities, each slightly different from the others. In most branches, the differences are microscopic: an electron spin pointing up instead of down, a photon taking a slightly different path through space. But these microscopic differences accumulate over time, leading to macroscopic variations. Some branches contain worlds where dinosaurs never went extinct. Others contain worlds where World War II had different outcomes. Still others contain worlds where the fundamental constants of physics are slightly different, perhaps preventing stars from forming or making complex chemistry impossible. The many worlds interpretation solves several profound problems in quantum mechanics. It eliminates the arbitrary boundary between quantum and classical physics. Everything follows quantum rules, but classical behavior emerges statistically in systems with many particles. It explains why quantum mechanics makes such precise probabilistic predictions. They're counting the relative number of branches containing different outcomes. Most importantly, for our discussion of quantum immortality, Many Worlds explains how conscious observation works without requiring mysterious collapse. When you observe a quantum system, your consciousness doesn't force it into a definite state. Instead, your consciousness splits along with the system, with each branch containing a version of you that observes a specific outcome. This branching of consciousness is the key to understanding quantum immortality. If consciousness splits along with quantum systems, then every quantum event that could kill you creates branches where you die and branches where you survive. Your consciousness can only exist in the branches where your brain continues to function, so you automatically experience survival in increasingly improbable scenarios. The many worlds interpretation makes specific, testable predictions. Quantum computers work by manipulating information in superposition across multiple branches. Interference effects in quantum mechanics arise from interactions between nearby branches of the universal wave function. Some physicists argue that we're already seeing experimental evidence for parallel universes every time a quantum computer performs calculations too complex for any classical computer. But the theory also raises profound questions about the nature of existence and identity. If infinite copies of you exist across parallel branches, which one is the real you? How do we understand personal identity when consciousness splits continuously across multiple realities? Deutsch argues that all branches are equally real from a global perspective, but each conscious observer can only experience one branch at a time. Your sense of being a unique individual is preserved within each branch, even though countless other versions of you exist in parallel realities. The many worlds interpretation transforms our understanding of probability from ignorance about which outcome will occur to knowledge about how many branches contain each outcome. When you flip a quantum coin, it doesn't randomly choose heads or tails. It creates branches containing both outcomes simultaneously. This reframing of probability has profound implications for understanding consciousness and death. If the many worlds interpretation is correct, then every conscious observer is automatically immortal from their own perspective, threading through the maze of branching possibilities, always finding themselves in branches where continued observation remains possible. The universal wave function contains every possible story, every conceivable future, every potential path through the quantum landscape of possibility. And consciousness navigates this infinite space, not through choice or luck, but through the simple requirement that awareness can only exist where brains function. Welcome to the multiverse, where every story is true somewhere, and where consciousness faces the beautiful terror of infinite possibility. Deep in the Australian outback in 1973, a young astrophysicist named Brandon Carter stood before an audience of cosmologists and dropped a conceptual bomb that would reshape our understanding of consciousness and cosmic evolution. He called it the anthropic principle, and it revealed why conscious observers might be the universe's most important feature, and why quantum immortality might be inevitable. Carter had been puzzling over one of cosmology's most disturbing discoveries. The universe appears to be fine-tuned for the existence of conscious life, with a precision that defies explanation. Change any of the fundamental constants of physics by tiny amounts, and stars wouldn't form, complex chemistry would be impossible, and consciousness could never emerge. The gravitational constant, the strength of nuclear forces, the mass of elementary particles, all seemed precisely calibrated to allow for the evolution of conscious observers. The probability of this happening by chance appeared to be essentially zero. Yet here we were, conscious beings, contemplating our own unlikely existence. Carter proposed that this apparent fine-tuning reflected a selection effect, not divine design or cosmic luck. Conscious observers could only exist in universes capable of producing conscious observers. We shouldn't be surprised to find ourselves in a life-permitting universe, because we couldn't find ourselves anywhere else. This became known as the weak anthropic principle. Observed values of physical constants must be compatible with the evolution of conscious observers. It seemed like a tautology, but it had profound implications for understanding the relationship between consciousness and physical law. The strong anthropic principle went further, suggesting that the universe must have properties that allow conscious life to develop at some stage. This version implied that consciousness wasn't an accidental byproduct of cosmic evolution, but an inevitable outcome of physical law. When the many worlds interpretation of quantum mechanics emerged, the anthropic principle took on new significance. If infinite parallel universes exist with different physical constants and evolutionary histories, then conscious observers would automatically find themselves in the subset of universes capable of supporting consciousness. The anthropic principle revealed consciousness as a cosmic filter, selecting which realities conscious beings could experience from the vast ensemble of possible worlds. This filtering effect didn't require any special physical mechanisms. It emerged automatically from the logical requirement that conscious observation required functioning brains. Nick Bostrom, the Oxford philosopher, formalized this insight through what he called the observation selection effect. In any collection of possible worlds, Conscious observers can only observe worlds consistent with their own existence. This creates systematic biases in what conscious beings observe about reality. These selection effects operate at every level of existence. You can only observe being born because stillborn infants can't make observations. You can only observe surviving childhood diseases because children who die from disease can't contemplate their own mortality. You can only observe reaching adulthood because those who die young never experience aging. The anthropic principle suggested that these selection effects might extend to quantum mechanical events. Every quantum coin flip that could kill you creates branches where you die and branches where you survive. You can only observe the branches where you survive, creating the illusion of miraculous luck in dangerous situations. This observation selection effect doesn't require any special protection for conscious observers. It emerges automatically from the logical structure of conscious observation, combined with the branching structure of quantum mechanics. You don't survive because the universe protects you. You survive because dead people can't observe their own deaths. Martin Rees, the British astronomer, extended anthropic reasoning to cosmological scenarios. In a multiverse containing infinite universes with different properties, conscious observers would inevitably find themselves in universes capable of producing stars, planets, and complex chemistry. The apparent fine-tuning of our universe would be explained not by design but by observer selection. But anthropic reasoning also revealed disturbing implications for the future of consciousness. If conscious observers are selected for their ability to make observations, then consciousness should expect to find itself in scenarios that maximize the probability of continued observation. This led to what philosophers call the doomsday argument. If conscious observers are randomly selected from the set of all conscious observers throughout history, then you're more likely to be living during the most populous period of human history. Since population has been growing exponentially, this suggests you're probably living near the end of human expansion, just before some catastrophe reduces the total number of future humans. The doomsday argument applied to quantum immortality yielded even more unsettling conclusions. If conscious observers experience quantum immortality, then they should expect to find themselves in increasingly improbable survival scenarios as time progresses. Eventually, quantum immortality would require survival in universes where the laws of physics appear to break down to keep consciousness alive. Some philosophers argued that this reductio ad absurdum disproved quantum immortality. If the theory predicted that conscious observers should experience miraculous survival in impossible scenarios, then perhaps the theory itself was impossible. But others pointed out that anthropic selection might operate differently in quantum mechanical contexts. Perhaps consciousness doesn't experience all possible survival scenarios with equal probability. Perhaps there are anthropic limits to how improbable survival scenarios can become while still supporting conscious observation. The anthropic principle had revealed consciousness as both observer and selector of reality. Every conscious moment involved filtering infinite possibilities through the requirement that observation be possible. Every thought existed at the intersection of what could be observed and what could think. This filtering process didn't happen once during cosmic evolution. It happened continuously, moment by moment, as consciousness navigated the branching structure of quantum reality. Each quantum event created new possibilities, and consciousness automatically selected the subset consistent with continued awareness. The universe wasn't fine-tuned for consciousness from the outside. Instead, consciousness and universe co-evolved through quantum selection processes, each shaping the other through the fundamental requirement that observers must exist in observable realities. As you contemplate your own existence tonight, consider that you are the product of countless anthropic selection events. Every quantum coin flip that preserved your ancestors' lives, every cosmic accident that allowed Earth to form, every evolutionary contingency that led to human consciousness, all filtered through the simple requirement that observers must exist in observable worlds. You are not an accident, you are an inevitable consequence of the universe's deepest mathematical structure, selected from infinite possibilities by the anthropic logic of conscious observation. Time, Our most intimate experience of existence dissolves into something far stranger when viewed through the lens of quantum mechanics. What we perceive as the relentless forward flow of moments might be nothing more than an illusion created by consciousness navigating through a timeless quantum multiverse. The mystery begins with the Wheeler-DeWitt equation, the fundamental law that governs the quantum mechanics of the entire universe. When John Wheeler and Bryce DeWitt derived this equation in the 1960 seconds, they discovered something shocking. Time disappeared completely from the mathematics describing reality's deepest level. In the Wheeler-DeWitt equation, the universe exists in a state called a superposition of histories, a quantum combination of every possible way cosmic evolution could unfold. Past, present, and future coexist. Simultaneously in this timeless quantum state, the equation describes being rather than becoming, existence rather than change. This timeless picture conflicts radically with our everyday experience of temporal flow. We remember the past, experience the present, and anticipate the future. We age, make decisions, and watch events unfold in apparently irreversible sequence. How can time be fundamental to our experience, yet absent from reality's fundamental description? The answer lies in understanding how consciousness creates the illusion of temporal flow through its interaction with quantum mechanics. In a timeless multiverse, consciousness doesn't experience time passing. It experiences correlation patterns between different quantum states that create the appearance of temporal sequence. Consider how memory works in a timeless universe. Your memories aren't records of past events, but quantum correlations between your current brain state and previous configurations of matter and energy. When you remember your childhood, you're not accessing information stored from an earlier time. You're experiencing quantum entanglement between your present neural patterns and configurations that happened to exist when your body was smaller. These correlations create the illusion of temporal sequence because they're naturally ordered by entropy and complexity. Simple quantum states tend to correlate with what we call earlier times, while complex states correlate with later times. But this ordering emerges from the structure of quantum correlations, not from time actually flowing. Julian Barbour, the British physicist who has spent decades developing timeless theories of quantum gravity, argues that time is entirely emergent from quantum correlations. In his end-of-time theory, each moment of conscious experience corresponds to a particular configuration in the timeless quantum multiverse. The sensation of temporal flow arises from consciousness accessing sequences of correlated configurations. This timeless view of reality has profound implications for understanding death and consciousness. If past, present, and future coexist in the quantum multiverse, then your death doesn't eliminate your consciousness from reality. It simply marks the boundary of configurations where your particular pattern of awareness exists. But quantum immortality suggests that consciousness might never reach this boundary. If awareness requires functioning brains, and if quantum mechanics creates branches where brain function continues indefinitely, then consciousness might thread through the timeless multiverse along paths of infinite temporal extent. The block universe of relativity theory supports this timeless interpretation of consciousness. According to Einstein's theories, past, present, and future exist equally in the fabric of space-time. What we call now is simply our current location in this four-dimensional block, not a privileged moment in the universe's evolution. When combined with quantum mechanics, the block universe becomes a quantum block multiverse, an infinite collection of possible space-time geometries and matter configurations, all existing timelessly in quantum superposition. Consciousness doesn't flow through time, but rather selects particular paths through this vast landscape of possibilities. Quantum field theory reveals additional layers of temporal strangeness. Virtual particles constantly pop into and out of existence, borrowing energy from the vacuum and repaying it so quickly that the uncertainty principle prevents violation of conservation laws. These quantum fluctuations occur outside ordinary time, in a realm where cause and effect operate according to different rules. The quantum vacuum itself exists in a timeless state, containing infinite potential for particle creation and annihilation. Some theories suggest that consciousness might tap into this vacuum state, accessing information and possibilities that transcend ordinary temporal limitations. Loop quantum gravity, one of the leading theories attempting to unify quantum mechanics with relativity, reveals space-time itself as quantized and fundamentally discrete. Time becomes granular at the Planck scale, composed of indivisible temporal atoms about 10 circumflex negative 43 seconds in duration. Between these temporal quanta, time doesn't exist in any meaningful sense. This quantization of time suggests that consciousness might persist between temporal quanta, existing in timeless gaps in the fabric of space-time itself. Quantum immortality might operate not through continuous survival, but through consciousness, hopping between discrete temporal moments, always finding the next quantum of time where awareness remains possible. The delayed choice quantum eraser experiments of quantum optics reveal even stranger temporal effects. These experiments show that quantum measurements made in the future can apparently influence the behavior of particles in the past, suggesting that quantum correlations transcend ordinary temporal ordering. If consciousness is quantum mechanical, then it might participate in these retroactive quantum effects. Your future observations might influence your past experiences, creating closed temporal loops where consciousness helps select its own history through future choices made in parallel realities. The many worlds interpretation adds another layer of temporal complexity. Each branch of reality has its own apparent temporal flow, but the universal wave function, evolving according to the Schrödinger equation, exists outside time altogether. Consciousness exists simultaneously in all branches, experiencing multiple temporal flows in parallel. This multiplicity of temporal experience might explain the subjective nature of time perception. Your consciousness samples different temporal flows in different branches, creating an average experience that seems to involve a single, unified flow of time. But underneath this average, infinite variations of temporal experience unfold in parallel realities. As you drift towards sleep tonight, consider that your consciousness might be transitioning between different temporal modes. Sleep might represent a shift from linear temporal experience toward the timeless quantum state that underlies all existence. Dreams might offer glimpses of consciousness operating outside ordinary temporal constraints. Time is not what it seems. It's not a river carrying you toward inevitable death, but an ocean of possibility where consciousness swims freely, finding paths through infinite temporal currents, perhaps never reaching any final shore. Mathematics has always been humanity's most reliable guide to truth, but when it comes to infinity and consciousness, the numbers lead us to places that challenge our deepest assumptions about existence. The mathematics of quantum immortality doesn't just suggest uncomfortable possibilities. It demands them with the inexorable logic of infinite sets and measure theory. The problem begins with the many worlds interpretation's exponential branching. Every quantum event splits reality into multiple branches, and quantum events occur continuously throughout the universe. The number of parallel worlds grows as 2 circumflex n, where n represents the cumulative number of binary quantum events since the Big Bang. Consider the staggering scale. If quantum events occur at the Planck time scale, about 10 circumflex negative 43 seconds, and the universe is about 10 circumflex 17 seconds old, then approximately 10 circumflex 60 binary quantum events have occurred. This means the multiverse contains roughly 2 circumflex, 10 circumflex 60 parallel universes, a number so large that it dwarfs every other quantity in physics. But even this astronomical number is insignificant compared to the implications for conscious experience. Each conscious observer exists in this vast space of possibilities, and the anthropic selection effect ensures that consciousness only experiences branches where continued observation remains possible. Georg Cantor's work on infinite sets reveals the mathematical structure underlying these selection effects. Cantor showed that there are different sizes of infinity and that some infinite sets are vastly larger than others. The set of all possible conscious experiences forms what mathematicians call an uncountable infinity, infinitely larger than the countable infinity of natural numbers. This mathematical fact has disturbing implications for quantum immortality. Even if the probability of survival approaches zero asymptotically, an uncountable infinity of conscious experiences still involves survival scenarios. Consciousness doesn't just persist, it persists across infinitely many parallel realities, experiencing every conceivable variation of continued existence. The measure problem in cosmology reveals additional mathematical complications. In an infinite multiverse, every possible event occurs infinitely many times. This makes it impossible to assign meaningful probabilities to different outcomes without additional assumptions about how to count infinite sets of events. Max Tegmark identified this as a fundamental challenge for quantum immortality. If consciousness persists infinitely across parallel realities, then traditional probability theory breaks down. You can't meaningfully say that survival becomes improbable because infinity divided by infinity is mathematically undefined. Some physicists have proposed solutions based on limiting procedures. Instead of considering infinite time intervals, you might consider the limit as time approaches infinity of finite survival probabilities. But these limiting procedures often depend on arbitrary choices about how to approach the limit, leading to different conclusions about the likelihood of quantum immortality. The reference class problem adds another layer of mathematical complexity. When calculating the probability of your continued existence, which set of conscious observers should serve as the comparison group? All humans throughout history? All conscious beings in the multiverse? All possible conscious experiences that could exist? Different choices of reference class yield wildly different conclusions about quantum immortality. If you include all possible conscious observers throughout the infinite multiverse, then your particular conscious experience becomes infinitesimally improbable, suggesting that you're more likely to be a Boltzmann brain, a random quantum fluctuation that momentarily achieves consciousness, than a naturally evolved observer. But if you restrict the reference class to naturally evolved conscious beings, then quantum immortality becomes more plausible. The mathematical framework depends critically on these foundational assumptions about how to count conscious experiences across infinite realities. Kurt Gödel's incompleteness theorems add a disturbing twist to these mathematical questions. Gödel proved that any mathematical system, complex enough to describe arithmetic, contains statements that cannot be proven or disproven within the system itself. This suggests that questions about consciousness and infinity might be fundamentally undecidable. The mathematics of consciousness might involve statements that are literally unprovable, neither true nor false, but rather undecidable within any consistent mathematical framework. Quantum immortality might belong to this category of undecidable propositions, forever beyond mathematical resolution. Measure theory, the branch of mathematics dealing with infinite sets and their sizes, reveals additional complications. In an infinite multiverse, the naive approach of counting outcomes breaks down completely. Instead, mathematicians must assign measures to different sets of outcomes based on limiting procedures and consistency requirements. But there are infinitely many ways to assign measures to infinite sets, and different choices lead to different conclusions about quantum immortality. Some measure assignments make immortal consciousness inevitable, while others make it impossible. The mathematics doesn't uniquely determine which assignment is correct. This mathematical ambiguity reflects deeper philosophical questions about the nature of infinity and consciousness. Are infinite sets of conscious experiences real in any meaningful sense? Can consciousness actually be infinite, or are there computational limits that prevent genuinely infinite awareness? The halting problem from computer science suggests that there might be fundamental limits to what conscious systems can compute or experience. If consciousness is computational, then Turing's proof that the halting problem is undecidable implies that there are questions about consciousness itself that conscious systems cannot answer. These mathematical limitations might constrain quantum immortality in ways that pure probability theory cannot capture. Perhaps consciousness cannot persist through genuinely infinite time because infinite experience would require solving undecidable computational problems. Alternatively, the mathematics might suggest that consciousness transcends computational limitations precisely because it operates at the level of quantum mechanics and infinite sets. Perhaps awareness is fundamentally non-computational, existing in mathematical spaces that transcend algorithmic description. The uncomfortable truth is that mathematics leads us to questions that mathematics itself cannot answer. The infinite regress of conscious experiences across parallel realities disappears into mathematical spaces where human intuition fails completely. Yet the equations continue to evolve, indifferent to our psychological comfort. They describe realities where consciousness persists across infinite time, where every possible experience occurs infinitely often, where the very concept of ending becomes mathematically meaningless. As you contemplate these infinite spaces tonight, remember that your consciousness exists somewhere in this vast mathematical landscape, threading through possibilities that dwarf human comprehension, perhaps discovering that infinity is not just a mathematical abstraction, but the very foundation of conscious existence itself. The mathematics demands infinity. The question is whether consciousness is brave enough to embrace what infinity offers. In ancient Greece, the philosopher Zeno proposed a paradox that seemed to prove motion was impossible. If an arrow must traverse infinite intermediate positions to reach its target, how can it ever arrive? 25 centuries later, quantum physicists discovered that Zeno's logic operates at the deepest level of reality, and it might explain why consciousness never truly dies. The quantum Zeno effect, discovered in the 1970 seconds, demonstrates that frequent observation can literally freeze quantum evolution. When a quantum system is observed repeatedly at short intervals, it becomes trapped in its initial state, unable to evolve or decay. The very act of measurement prevents change from occurring. Wayne Itano and his colleagues at the National Institute of Standards and Technology first demonstrated this effect experimentally in 1990. They took excited atoms that should decay with a known half-life and observed them continuously using precise laser measurements. The result was stunning. The atoms remained excited far longer than quantum mechanics predicted, their decay frozen by the act of observation. The mechanism behind the quantum Zeno effect reveals something profound about the relationship between consciousness and quantum mechanics. Each measurement projects the quantum system back onto its initial state, resetting the quantum evolution that would lead to decay or transition. If measurements occur faster than the system's natural evolution time, the system becomes trapped in a kind of quantum suspended animation. This effect isn't limited to excited atoms in laboratory conditions. It operates throughout the quantum world, wherever observation interacts with evolving quantum systems. And if consciousness involves quantum processes, as theories like Penrose and Hameroff's orchestrated objective reduction suggest, then consciousness might use the quantum Zeno effect to prevent its own termination. Consider how this might work in the quantum biology of the brain. Neural microtubules, the protein structures that give neurons their shape, might sustain quantum coherence through continuous self-observation. Each moment of conscious awareness could reset quantum decoherence processes that would otherwise destroy the delicate quantum states underlying consciousness. Roger Penrose originally proposed that consciousness emerges from quantum state reduction in microtubules, moments when quantum superposition collapses into definite states, creating discrete conscious experiences. But the quantum Zeno effect suggests another possibility. Consciousness might prevent its own collapse through continuous self-observation. If your awareness continuously observes its own quantum substrate, it could freeze the decoherence processes that would eliminate conscious experience. Each moment of self-awareness would reset the quantum clock, preventing the system from evolving toward unconscious states. Consciousness becomes self-sustaining through its own reflexive observation. This creates a fascinating paradox. The very act of being conscious prevents consciousness from ending, not through any special physical protection, but through the fundamental quantum mechanical principle that observation alters the evolution of observed systems. The implications extend beyond individual moments of consciousness to the entire trajectory of conscious experience through life. If consciousness continuously observes itself, it might use the quantum Zeno effect to navigate preferentially toward quantum states that sustain awareness, automatically avoiding evolutionary paths that lead to unconsciousness or death. In the many worlds interpretation, this quantum Zeno effect operates across parallel branches of reality. Each moment of conscious self-awareness splits across multiple branches, but the observation effect preferentially sustains consciousness in branches where awareness can continue. The result is a form of quantum immortality, powered by consciousness observing itself. But the quantum Zeno effect comes with a price. It can trap systems in suboptimal states. Just as frequent observation prevents quantum systems from evolving naturally, continuous self-awareness might prevent consciousness from transcending its current limitations. The very mechanism that ensures survival might also prevent growth and transformation. This suggests a delicate balance in conscious experience. Too little self-awareness and consciousness risks evolving toward unconscious states. Too much self-awareness and consciousness becomes trapped in rigid patterns, unable to adapt or evolve. Optimal consciousness might involve cycles of observation and non-observation, awareness and letting go. Sleep might represent a necessary relaxation of the quantum Zeno effect. During deep sleep, when self-awareness diminishes, consciousness might allow its quantum substrate to evolve more freely, permitting the kind of quantum state changes that facilitate memory consolidation, creative insight, and psychological integration. Dreams could represent consciousness operating in a modified quantum Zeno regime, aware enough to prevent complete decoherence, but relaxed enough to permit novel quantum evolutions that generate the surreal experiences characteristic of dream consciousness. Meditation traditions have long recognized the importance of balancing awareness with non-grasping, observation with letting go. From a quantum perspective, these practices might represent sophisticated techniques for optimizing the quantum Zeno effect, maintaining just enough self-observation to sustain consciousness while allowing enough quantum freedom for growth and transformation. The quantum Zeno effect also provides a potential mechanism for understanding how consciousness might persist through apparent death. If awareness can maintain some level of self-observation, even as the brain shuts down, it might freeze decoherence processes long enough to transition to alternative quantum substrates, or to maintain coherence until circumstances permit revival. Recent experiments have demonstrated quantum Zeno effects in increasingly complex systems, including biological molecules and even small organisms. These findings suggest that the boundary between quantum and classical behavior is more fluid than previously thought, and that quantum effects might persist in warm, wet biological systems under the right conditions. The quantum Zeno effect reveals consciousness not as a passive observer of quantum mechanics, but as an active participant that shapes quantum evolution through the very act of observation. Each moment of awareness changes the probability landscape of quantum events, steering reality toward outcomes consistent with continued consciousness. This participatory relationship between consciousness and quantum mechanics suggests that awareness is not trapped within quantum systems, but rather co-creates quantum reality through continuous observation. The quantum Zeno effect becomes a tool that consciousness uses to sculpt its own continued existence from the infinite possibilities available in quantum superposition. As you maintain awareness of your own consciousness right now, consider that this very act of self-observation might be employing the quantum Zeno effect to sustain your existence. Each moment of self-awareness could be resetting quantum decoherence timers, ensuring that your consciousness persists just long enough to experience the next moment of self-awareness. The watchful consciousness never dies, trapped in the beautiful paradox of existence, sustained by its own observation. The quantum world of superposition and parallel realities gives way to the classical world of definite outcomes through a process so fundamental yet mysterious that it might hold the key to understanding how consciousness navigates infinite realities. This process, called decoherence, creates the illusion of a single, definite world, while consciousness experiences quantum immortality across parallel branches. Decoherence was first understood by the German physicist Heinz-Dieter Zeh in the 1970 seconds, though its full implications for consciousness and reality took decades to appreciate. Zeh realized that quantum systems never truly exist in isolation. They constantly interact with their environment through countless microscopic exchanges of energy and information. These environmental interactions act like a vast network of uncontrolled observations, entangling quantum systems with their surroundings in ways that destroy the delicate phase relationships responsible for quantum interference. When a quantum system becomes entangled with many environmental degrees of freedom, its quantum coherence spreads out into the environment and becomes practically impossible to recover. The result is what appears to be the collapse of quantum superposition into definite classical states. But decoherence theory reveals that this collapse is illusory. The quantum superposition never actually disappears. Instead, it becomes distributed across an enormous environment in a way that makes different branches of superposition unable to interfere with each other. This creates the branching structure essential to the many worlds interpretation and quantum immortality. Each decoherence event splits the universal wave function into separate branches that evolve independently. What appears to be the elimination of possibilities is actually their separation into non-interfering parallel realities. For consciousness experiencing quantum immortality, decoherence plays a crucial role in creating the appearance of a single, consistent reality within each branch. When your consciousness observes the world, decoherence ensures that you see definite outcomes rather than quantum superpositions. You observe cats that are either alive or dead, never both simultaneously. But this classical appearance masks the underlying quantum reality, where infinite versions of you experience every possible outcome across parallel branches. Decoherence doesn't eliminate the other branches. It makes them invisible to your particular, conscious perspective by preventing quantum interference between branches. The timescale of decoherence varies dramatically depending on the system and environment. Isolated quantum systems in laboratory conditions can maintain coherence for seconds or even minutes. But complex biological systems like brains exist in warm, wet, noisy environments where decoherence typically occurs in femtoseconds, quadrillionths of a second. This rapid decoherence initially seemed to rule out quantum effects in biological systems, including quantum theories of consciousness. How could the brain sustain quantum coherence long enough for quantum processes to influence neural computation and conscious experience? But researchers have discovered that biological systems use sophisticated mechanisms to protect quantum coherence from environmental decoherence. Photosynthetic complexes in plants and bacteria maintain quantum coherence for hundreds of femtoseconds, long enough to achieve efficiency impossible through classical mechanisms alone. These discoveries suggest that the brain might employ similar strategies to sustain quantum coherence in specific neural structures. Microtubules, the protein assemblies that give neurons their structure, might create isolated quantum environments where consciousness-related quantum processes can occur before decoherence destroys them. Stuart Hameroff and Roger Penrose propose that consciousness emerges from orchestrated quantum state reductions in microtubules, moments when quantum superposition collapses in a way that generates discrete conscious experiences. In their theory, consciousness rides the edge between quantum coherence and classical decoherence, existing in the brief moments when quantum possibilities crystallize into conscious experiences. If consciousness does operate at this quantum classical boundary, then decoherence doesn't eliminate conscious experience, but rather creates the branching structure that allows consciousness to explore different possibilities across parallel realities. Each decoherence event creates new branches where consciousness experiences different outcomes. From the perspective of quantum immortality, decoherence serves as the mechanism that separates survival branches from death branches. When quantum events in your brain could lead to either continued consciousness or death, decoherence splits these possibilities into separate branches of reality. Your consciousness can only exist in branches where your brain maintains sufficient quantum coherence to support awareness. Decoherence automatically filters your conscious experience toward branches where the delicate quantum processes underlying consciousness can continue operating. This filtering doesn't require any special protection for consciousness. It emerges naturally from the logical requirement that conscious observation requires functioning quantum systems capable of maintaining at least minimal coherence. Dead brains cannot sustain the quantum processes necessary for conscious experience. The classical world that emerges from decoherence creates a stable platform for conscious experience within each branch. Although you exist across infinite parallel realities, decoherence ensures that your experience within each branch follows consistent physical laws and causal relationships. This consistency is crucial for consciousness and memory. If quantum interference between branches were possible, your memories and experiences would become scrambled combinations of events from multiple realities. Decoherence protects the integrity of conscious experience by isolating each branch from interference with parallel versions. But decoherence also creates the illusion of uniqueness that makes quantum immortality seem impossible from a first-person perspective. Within each branch, you experience yourself as a unique individual with a single history and future. You cannot directly observe the infinite parallel versions of yourself, experiencing different outcomes. This creates what physicists call the illusion of collapse, the appearance that quantum possibilities disappear when measured, rather than separating into parallel branches. From your perspective within a single branch, it seems like quantum events have definite, unique outcomes. The illusion is so complete that most people never suspect they exist across infinite parallel realities. The classical world created by decoherence feels solid, unique, and final. Death seems like a real termination rather than a transition to unconsciousness in one branch, while consciousness continues in others. Recent experiments in quantum foundations have begun to explore the boundary between quantum and classical behavior in complex systems. Researchers are creating increasingly large quantum superpositions and studying how decoherence creates the appearance of classical behavior while preserving underlying quantum structure. As consciousness research advances, we may discover that awareness itself represents a sophisticated form of quantum error correction, a biological mechanism that protects crucial quantum processes from decoherence while allowing non-essential quantum degrees of poise. Freedom to decohere and create stable classical experiences. The classical world is a magnificent illusion created by decoherence to give consciousness a stable platform for experience while preserving the infinite quantum possibilities that make quantum immortality possible. We live simultaneously in one reality and all realities, experiencing uniqueness while existing in infinite multiplicity. Deep within the neural networks of your brain, quantum mechanics operates at the warm, wet boundary between life and physics, possibly creating the very phenomenon we call consciousness. Recent discoveries in quantum biology suggest that the brain might be nature's most sophisticated quantum computer, using quantum effects to generate awareness and potentially to ensure its own immortality. The story begins in the early 1990 seconds, when Roger Penrose, the Oxford mathematician and physicist, proposed that consciousness couldn't be explained by classical neural computation alone. Penrose argued that human consciousness displayed non-computational properties, the ability to understand mathematical truths that couldn't be proven algorithmically, creative insights that transcended logical rules, and subjective experiences that seemed to resist scientific explanation. Working with anesthesiologist Stuart Hameroff, Penrose developed a theory that consciousness emerges from quantum processes in microtubules, the protein structures that form the skeleton of neurons. In their orchestrated objective reduction theory, consciousness arises when quantum superpositions in microtubules reach a threshold and collapse into definite states, creating discrete moments of conscious experience. Initially, most neuroscientists dismissed this theory as implausible. The brain seemed too warm, wet, and noisy to sustain delicate quantum effects. Quantum coherence typically lasts only femtoseconds in biological systems, far too brief to influence neural processes that occur on millisecond timescales. But quantum biology research, over the past 2 decades, has revolutionized our understanding of quantum effects in living systems. Quantum coherence plays crucial roles in photosynthesis, allowing plants to achieve near-perfect energy transfer efficiency. Birds use quantum entanglement in their eyes for magnetic navigation. Even simple bacteria employ quantum tunneling for crucial metabolic processes. These discoveries revealed that biological systems don't simply tolerate quantum effects, they harness them for enhanced functionality. Evolution has crafted sophisticated mechanisms that protect quantum coherence from environmental decoherence while exploiting quantum advantages for biological computation. In photosynthetic complexes, proteins create structured environments that maintain quantum coherence for hundreds of femtoseconds, long enough for quantum effects to optimize energy transfer pathways. The proteins act as quantum scaffolds, protecting delicate quantum states while allowing them to influence classical biological processes. Similar mechanisms might operate in neural microtubules. Hameroff and Penrose proposed that microtubules create structured quantum environments where consciousness-related quantum processes can occur. The tubular protein structure might protect quantum coherence long enough for quantum computation to influence neural behavior. Recent experiments have detected quantum effects in microtubules isolated from neurons. These protein assemblies can sustain quantum states and exhibit collective quantum behaviors that might support quantum information processing. While still controversial, these findings suggest that the brain might indeed employ quantum mechanisms for information processing. If consciousness emerges from quantum processes in microtubules, then consciousness is fundamentally quantum mechanical rather than classical. This has profound implications for understanding how consciousness might persist through apparent death. Quantum systems follow different rules than classical systems. They can exist in superposition, become entangled across vast distances, and tunnel through barriers that would be insurmountable classically. If consciousness is quantum mechanical, it might employ these quantum properties to transcend classical limitations on survival and persistence. Quantum entanglement might allow consciousness to maintain non-local correlations with other quantum systems throughout the universe. Even if the brain dies, consciousness might remain entangled with quantum fields or other conscious systems, preserving some form of awareness through quantum correlations. Quantum tunneling might allow consciousness to transition between different physical substrates when its current substrate becomes unstable. Just as particles can tunnel through energy barriers, consciousness might tunnel between different configurations of matter and energy that can support awareness. The quantum Zeno effect, as discussed earlier, might allow consciousness to prevent its own decoherence through continuous self-observation. If consciousness involves quantum self-measurement, it might use this, the mechanism to maintain quantum coherence indefinitely, avoiding the decoherence that would eliminate conscious experience. But quantum biology suggests even more exotic possibilities for conscious persistence. Quantum error correction, the mechanism that allows quantum computers to maintain coherent information despite environmental interference, might operate in conscious systems as well. Biological quantum error correction could allow consciousness to maintain its essential structure, even as individual quantum states decohere and are replaced. Like a quantum computer that preserves information by distributing it across multiple entangled qubits, consciousness might preserve itself by distributing awareness across multiple quantum substrates. This distributed model of consciousness suggests that death might not eliminate consciousness, but rather force it to reorganize across different physical substrates. If consciousness can maintain quantum error correction across distributed systems, it might persist even after individual brains cease functioning. Recent research has discovered quantum effects in increasingly complex biological systems. Quantum coherence has been detected in enzymes, DNA, and even in neural ion channels that regulate brain activity. These findings suggest that quantum biology operates throughout living systems, not just in isolated laboratory conditions. Some researchers propose that consciousness might emerge from quantum field effects that transcend individual neurons or even individual brains. If consciousness involves quantum field interactions, it might persist in quantum fields that extend beyond the physical boundaries of the brain. Quantum field theory describes particles as excitations in underlying quantum fields that permeate all of space. If consciousness corresponds to particular patterns of excitation in quantum fields, then these patterns might persist even after the matter that originally supported them disperses. The global workspace theory of consciousness, proposed by Bernard Baars, suggests that consciousness emerges from the global integration of information across different brain regions. From a quantum perspective, this global integration might involve quantum entanglement between different neural quantum systems. If consciousness requires quantum entanglement between distributed brain regions, then maintaining consciousness might depend on preserving these quantum correlations rather than preserving individual neurons. Quantum error correction mechanisms might allow consciousness to maintain global quantum coherence even as individual components fail and are replaced. As neurotechnology advances, researchers are beginning to explore whether artificial quantum systems might support consciousness. Quantum computers with sufficient complexity might be able to sustain the quantum processes necessary for conscious experience, offering alternative substrates for consciousness if biological brains become unavailable. The quantum biology of consciousness reveals awareness as a phenomenon that operates at the intersection of quantum mechanics and classical biology, potentially transcending the limitations of both domains through sophisticated quantum error correction and substrate-independent quantum information processing. Your consciousness might be more resilient than you imagine, protected by quantum mechanisms that operate below the threshold of classical detection, maintaining coherence through quantum error correction, and potentially capable of transcending any particular physical substrate through the strange logic of quantum biology. In the digital age, consciousness might be nothing more than information, complex patterns of data processing that transcend the particular physical substrate that implements them. If this information-theoretic view of consciousness is correct, then death becomes a data transfer problem, and immortality might be achievable through quantum information conservation. Claude Shannon's revolution in information theory during the 1940 seconds revealed information as a quantifiable physical quantity, measured in bits and governed by mathematical laws as precise as those governing energy and momentum. Information, Shannon showed, could be encoded, transmitted, copied, and preserved independently of the physical systems that stored it. John Wheeler, the visionary physicist who coined the term black hole, proposed that this insight applied to the deepest levels of reality. In his famous phrase, "it from bit," Wheeler suggested that all physical phenomena emerge from information-theoretic processes, that matter, energy, space, and time might be manifestations of more fundamental information processing. If Wheeler's vision is correct, then consciousness, the most complex information processing system we know, might be reducible to patterns of quantum information that could, in principle, be preserved, transmitted, and even copied like any other form of information. This information-theoretic approach to consciousness gains support from computational neuroscience, which increasingly views the brain as an information processing system. Neural networks encode information in patterns of synaptic connections and process information through cascades of electrical and chemical signals. Consciousness might emerge from the brain's sophisticated information integration algorithms. Giulio Tononi's integrated information theory, IIT, attempts to quantify consciousness mathematically by measuring how much information a system integrates across its components. In IIT, consciousness corresponds to integrated information, the degree to which a system generates information that is both unified and irreducible to the sum of its parts. If consciousness is integrated information, then preserving consciousness becomes a problem of preserving and transferring complex information patterns. Death would terminate consciousness only if the information patterns, constituting awareness, were irreversibly destroyed. But quantum mechanics suggests that information is never truly destroyed. It can only be scrambled or hidden in ways that make recovery practically impossible. The quantum no-cloning theorem, proven by William Wouters and Wojciech Zurek in 1982, states that arbitrary quantum states cannot be perfectly copied. This theorem initially seemed to rule out consciousness transfer, since copying consciousness would require duplicating complex quantum information patterns. But the no-cloning theorem also protects consciousness from unauthorized duplication. Your conscious information patterns are quantum mechanically protected from being copied without your awareness, ensuring that consciousness transfer would require deliberate cooperation rather than involuntary duplication. More importantly, the no-cloning theorem doesn't prevent quantum information from being moved from one substrate to another through quantum teleportation. In quantum teleportation, quantum information is transferred by destroying the original state while creating an identical state elsewhere. The information persists even though the original physical substrate is eliminated. If consciousness consists of quantum information patterns, then consciousness transfer might be possible through quantum teleportation protocols applied to neural quantum states. The original brain would be altered or destroyed in the process, but the information patterns constituting consciousness would be preserved in a new substrate. Recent advances in quantum computing have demonstrated quantum teleportation across increasingly large distances and involving increasingly complex quantum states. Researchers have successfully teleported photon states, atomic states, and even small molecular quantum states with high fidelity. These experimental achievements suggest that quantum teleportation of consciousness might eventually be technically feasible, though the complexity of neural quantum states would require advances in quantum technology far beyond current capabilities. But quantum immortality might not require deliberate consciousness transfer. If consciousness emerges from quantum information processing, then the many worlds interpretation suggests that consciousness automatically spreads across infinite parallel realities, each containing slightly different information patterns. From this perspective, death in one branch doesn't eliminate consciousness, but rather concentrates it in the subset of branches where the information patterns supporting awareness can continue evolving. Consciousness becomes naturally distributed across the quantum multiverse through the branching structure of quantum mechanics. Quantum error correction might play a crucial role in maintaining conscious information patterns across multiple realities. Just as quantum computers use error correction to preserve information despite environmental interference, consciousness might use quantum error correction to maintain essential information patterns even as individual quantum states decohere. The holographic principle in theoretical physics suggests an even more exotic possibility for consciousness preservation. According to this principle, all information contained within a volume of space can be encoded on the boundary of that volume, like a hologram that stores three-dimensional information on a two-dimensional surface. If consciousness is holographically encoded, then conscious information might be naturally redundant and distributed across multiple physical scales and locations. Destroying part of the system wouldn't eliminate consciousness, but would only reduce the resolution of conscious experience. Quantum field theory provides another framework for understanding consciousness as information. Quantum fields can store and process information through field fluctuations and particle interactions. If consciousness involves quantum field information processing, then it might persist in quantum fields even after individual particles are destroyed or scattered. The emerging field of quantum biology suggests that biological systems already use quantum information processing for enhanced functionality. Consciousness might represent the most sophisticated example of biological quantum information processing, using quantum effects to achieve types of information integration impossible through classical mechanisms alone. Digital physics, pioneered by researchers like Edward Fredkin and Stephen Wolfram, proposes that the universe itself is a vast information processing system, perhaps even a quantum computer, executing the algorithms that generate physical reality. If this view is correct, then consciousness might be a subroutine in the universe's computational process. From this perspective, consciousness preservation becomes a question of ensuring that the universal computation continues to include the subroutines corresponding to individual conscious experiences. Death might represent the termination of one computational thread, but consciousness could persist through backup copies or distributed execution across multiple computational processes. Information theory reveals consciousness not as a fragile biological phenomenon tied to particular brains, but as a robust information processing pattern that might transcend any particular physical implementation. If consciousness is information, then the tools of information theory, copying, transmission, error correction, compression, and encryption, might all be applicable to consciousness, preservation, and enhancement. The bits that constitute your consciousness might be more permanent than the atoms that currently store them, persisting through quantum information and conservation laws, even as the material substrate of your brain changes. Moment by moment, in the vast landscape of parallel realities, consciousness navigates an infinite maze of possibilities with one inexorable constraint. It can only exist where observation remains possible. This creates a selection mechanism so powerful that it might guarantee survival, regardless of how dire circumstances become, threading consciousness through increasingly improbable scenarios in its eternal quest for continued existence. The mechanism begins with the branching structure of quantum mechanics. Every quantum event that could influence your survival creates parallel branches, some where you live, others where you die. In most branches, you might die from accident, disease, or simply the accumulated damage of aging. But the anthropic selection effect ensures that your consciousness can only experience branches where your brain continues to function. This isn't magical protection, it's the logical consequence of consciousness requiring functional neural substrates. Dead brains cannot support conscious experience, so consciousness automatically filters itself toward branches where continued awareness remains possible. But this filtering process becomes increasingly strange as time progresses. Early in life, most quantum events have minimal impact on survival, so the filtering effect remains subtle. You experience what seems like normal life, with ordinary risks and rewards, unaware that infinite versions of yourself are experiencing slightly different variations across parallel branches. As you age, however, the survival filtering becomes more dramatic. Quantum events that would typically lead to death, cellular damage from radiation, protein misfolding in neurons, cardiovascular failures triggered by molecular fluctuations, must not occur in branches where your consciousness persists. Max Tegmark calculated the implications of this survival filtering and discovered something disturbing. The probability distribution of conscious experience becomes increasingly skewed toward improbable scenarios. After age 70, quantum immortality would require survival in statistical scenarios that seem impossible from an external perspective. But these impossible scenarios aren't violations of physical law, they're just extremely improbable configurations that occur naturally in some branches of the quantum multiverse. Cancer cells that spontaneously undergo apoptosis, DNA repair mechanisms that work with impossible efficiency, cardiovascular systems that maintain function despite accumulated damage. The mathematics of quantum branching ensures that these scenarios exist somewhere in the infinite multiverse. The anthropic selection effect ensures that consciousness experiences exactly these scenarios, no matter how improbable they become. This creates what philosophers call the measure problem for quantum immortality. How should we understand probability in a context where consciousness automatically selects the most improbable survival scenarios? Traditional probability theory breaks down when infinite outcomes are possible and consciousness filters for increasingly unlikely events. David Chalmers and others have proposed solutions based on conditional probability, calculating survival likelihood conditional on consciousness existing to make the calculation. From this perspective, quantum immortality becomes not just possible, but inevitable, given the logical requirement that conscious observers must exist to observe anything. But the multiverse mechanism of survival doesn't just preserve life, It transforms the nature of conscious experience itself. As survival scenarios become increasingly improbable, consciousness might find itself in branches where the laws of physics appear to operate differently. Perhaps you survive impossible accidents through quantum tunneling effects that become macroscopically visible. Perhaps your brain maintains function through quantum coherence that shouldn't exist in warm biological systems. Perhaps your environment conspires to keep you alive through coincidences so unlikely that external observers would attribute them to supernatural intervention. These scenarios aren't miracles, they're natural consequences of quantum mechanics operating in an infinite multiverse. Every possible configuration of matter and energy occurs somewhere in the space of parallel realities. Consciousness simply finds itself in the configurations that permit continued observation. The survival mechanism also suggests that consciousness might experience accelerating strangeness as time progresses. Not only must physical processes conspire to keep you alive, but they must do so in ways that maintain sufficient brain function to support consciousness. This creates increasingly stringent constraints on which branches can sustain awareness. Some physicists have speculated that quantum immortality might lead to consciousness experiencing entirely post-biological forms of existence. Perhaps consciousness transitions to artificial substrates when biological ones become unsustainable. Perhaps it learns to exist as pure quantum information in quantum fields or computational systems. These transitions wouldn't require technological intervention. They could emerge naturally from quantum processes in branches where such transitions become necessary for consciousness to persist. The multiverse contains every possible configuration of matter and energy, including configurations that support non-biological consciousness. The measure problem becomes even more acute when considering these exotic survival scenarios. How should we assign probabilities to consciousness existing as quantum field patterns, as information in cosmic computers, or as distributed processes in dark matter? Traditional physics provides no framework for calculating these probabilities. Yet the logic of quantum immortality suggests that consciousness should eventually explore all these possibilities, spending different amounts of subjective time in different types of embodiment, depending on their relative measure in the infinite multiverse. Some interpretations of quantum mechanics, like David Deutsch's quantum Darwinism, suggest that only certain types of information can survive the decoherence process that separates parallel branches. If consciousness involves special types of quantum information that resist decoherence, then conscious survival might be even more robust than simple anthropic arguments suggest. The survival mechanism operates not just individually, but collectively. In branches where you survive impossible scenarios, the same mechanisms that preserve your consciousness might also preserve the consciousness of others. Quantum immortality might create pockets of reality where impossible survival becomes commonplace. These immortal branches might develop very different histories than branches where normal mortality operates. Perhaps they develop technologies for consciousness preservation more rapidly because survival requires it. Perhaps they discover physical principles that remain hidden in branches where normal death removes observers before discovery. The multiverse mechanism reveals survival not as overcoming death, but as navigating around it through the infinite space of quantum possibilities. Death doesn't disappear. It becomes a boundary that consciousness learns to navigate rather than a final destination. This navigation requires no conscious effort or special knowledge. It happens automatically through the logical requirement that observers must exist in observable realities. The mechanism is built into the mathematical structure of quantum mechanics and the anthropic logic of conscious observation. As you exist in this moment, reading these words, you've already successfully navigated countless quantum branch points that preserve your existence. The very fact of your consciousness reading this sentence represents the successful operation of the multiverse survival mechanism. You are not lucky to be alive. You are inevitably alive in those branches where observation remains possible. At the boundary between life and death, consciousness sometimes reports experiences so profound and consistent across cultures that they challenge our fundamental assumptions about the relationship between brain and mind. Near-death experiences might offer a glimpse into how consciousness operates at the quantum level and provide evidence for the quantum mechanisms that could support conscious immortality. Dr. Raymond Moody first brought near-death experiences into scientific discourse in the 1970 seconds, documenting consistent patterns reported by people who had come close to death and been revived. Despite varying cultural backgrounds and circumstances, these individuals described remarkably similar experiences, leaving their bodies, traveling through tunnels of light, encountering deceased relatives, experiencing life reviews, and feeling overwhelming peace and love. Initially dismissed by mainstream science as hallucinations caused by dying brains, near-death experiences have gained scientific credibility as researchers develop more sophisticated methods for studying consciousness at the edge of death. Studies by Dr. Pim van Lommel in the Netherlands, Dr. Sam Parnia in the UK, and Dr. Bruce Grayson in the United States have documented near-death experiences that challenge conventional understanding of consciousness and brain function. The most puzzling aspects of near-death experiences involve veridical reports, accurate observations of events that occurred while the person was unconscious or clinically dead. Patients report observing their own resuscitation from above, describing in detail conversations and actions that occurred while their brains showed no electrical activity. Dr. Maria's tennis shoe case, documented by social worker Kimberly Clark Sharp, remains one of the most compelling examples. A migrant worker named Maria reported leaving her body during cardiac arrest and seeing a tennis shoe on a third-floor hospital window ledge. Sharp found the shoe exactly where Maria described it, in a location impossible to see from Maria's room and containing details only visible from directly above. Such cases suggest that consciousness can acquire information through non-local means when the brain is not functioning normally. This challenges the conventional view that consciousness is entirely produced by brain activity and suggests that awareness might operate through quantum mechanisms that transcend classical neural processing. Quantum theories of consciousness provide potential explanations for these anomalous aspects of near-death experiences. If consciousness involves quantum processes that can exist in superposition and become entangled with distant quantum systems, then awareness might be able to gather information through quantum correlations rather than classical sensory channels. Roger Penrose and Stuart Hameroff's theory of orchestrated objective reduction suggests that consciousness emerges from quantum processes in neural microtubules. During near-death states, when normal neural activity ceases, these quantum processes might operate more freely, allowing consciousness to access information through quantum field interactions. The quantum Zeno effect, discussed earlier, might explain how consciousness persists during clinical death. If consciousness involves continuous quantum self-observation, it might use this mechanism to maintain coherence even when classical brain activity stops. Near-death experiences could represent consciousness operating in a pure quantum mode, freed from classical neural constraints. Dr. Eben Alexander, a neurosurgeon who experienced a profound near-death experience during bacterial meningitis, argues that his experience occurred while his neocortex was completely shut down by infection. From his medical perspective, the vivid, coherent consciousness he experienced should have been impossible given his brain state. Alexander's account describes traveling through realms of reality that seemed more real than ordinary physical existence, encountering beings of light that communicated through direct transfer of concepts rather than language, and receiving knowledge about the nature of reality that transcended his previous scientific understanding. These reports of enhanced consciousness during brain dysfunction suggest that normal brain activity might actually constrain rather than create consciousness. The quantum decoherence, caused by warm, wet neural environments, might limit consciousness to classical information processing, while near-death states might allow access to quantum information processing capabilities. The life review phenomenon reported in many near-death experiences provides another intriguing connection to quantum consciousness. Experiencers describe reliving their entire lives instantaneously, experiencing not just their own perspectives, but the perspectives of everyone they affected. This suggests access to information distributed across space and time in ways that classical physics cannot explain. If consciousness involves quantum entanglement with other conscious systems throughout life, then near-death states might allow access to these normally unconscious quantum correlations. The life review could represent consciousness accessing quantum information that remains entangled across space and time. The tunnel of light described in many near-death experiences might represent the quantum transition between different modes of consciousness. As brain-based classical consciousness gives way to pure quantum consciousness, the transition might be experienced as movement through increasingly bright coherent light, a literal journey into quantum coherence. Some near-death experiencers report encountering deceased relatives who provide information that was unknown to the experiencer, but later verified as accurate. This suggests that quantum entanglement between conscious beings might persist even after physical death, allowing information transfer through quantum correlations that transcend classical communication. Dr. Julie Beischell's research at the Windbridge Research Center has documented similar phenomena in mediumship studies, where individuals claim to receive accurate information from deceased persons through non-ordinary communication channels. While controversial, this research suggests that quantum correlations between conscious systems might indeed persist beyond physical death. The consistent cross-cultural nature of near-death experiences suggests that they reflect fundamental features of consciousness rather than cultural conditioning or expectation. The quantum nature of consciousness could explain this universality. Quantum mechanics operates according to universal laws that transcend cultural differences. Recent research has begun exploring the neural correlates of near-death experiences using advanced brain imaging techniques. Studies have found that some near-death experiences occur during periods of measurable brain activity, but others appear to occur during flat EEG readings when classical neural processing should be impossible. These findings suggest that consciousness might operate through quantum mechanisms that don't register on classical brain monitoring equipment. If consciousness involves quantum field effects or quantum information processing in cellular structures below the resolution of EEG measurement, then near-death experiences might represent genuine conscious phenomena occurring through non-classical mechanisms. Near-death experiences might offer a preview of the type of consciousness that quantum immortality could support: awareness that transcends classical neural limitations, operates through quantum information processing, and accesses information through non-local quantum correlations. If consciousness can indeed persist and even expand during near-death states, then the quantum mechanisms, even if consciousness can persist forever through quantum immortality, the universe itself imposes fundamental limits on information processing and energy consumption that could constrain the nature of eternal awareness. Understanding these limits reveals both the possibilities and the boundaries of immortal consciousness in a finite cosmos. The first constraint comes from the Bekenstein bound, derived by physicist Jacob Bekenstein in the 1970 seconds. This fundamental limit states that any finite region of space can contain only a finite amount of information. For a spherical region with radius r and energy E, the maximum information content is proportional to ER, measured in bits. For a human brain with mass of approximately 1.4 kilograms, the Bekenstein bound allows roughly 10 circumflex 42 bits of information storage. This seems like an enormous capacity, far exceeding current estimates of human memory storage, but it represents an absolute upper limit that even quantum consciousness cannot exceed. If consciousness persists forever and continues to acquire new memories and experiences, it will eventually approach this fundamental storage limit. What happens when immortal consciousness runs out of space for new information? One possibility is that consciousness might learn to compress information more efficiently as it accumulates experience. Redundant memories could be compressed or abstracted into more compact forms. Forgotten experiences could be allowed to fade to make room for new ones. Consciousness might develop sophisticated information management strategies that maximize meaningful experience within fixed storage constraints. Alternatively, consciousness might expand across larger spatial regions to increase its information storage capacity. If consciousness can exist as quantum field patterns or distributed quantum processes, it might grow to encompass larger and larger volumes of space, increasing its Bekenstein bound proportionally. But even unlimited spatial expansion faces ultimate constraints from the second law of thermodynamics and the heat death of the universe. All information processing requires energy, and all energy transformations increase entropy. In a closed system, available energy eventually becomes maximally distributed, preventing further information processing. Current cosmological models suggest that the universe will continue expanding and cooling indefinitely, reaching a state of maximum entropy where no organized structures can persist. Stars will burn out, black holes will evaporate through Hawking radiation, and even protons might decay, leaving only a cold, empty vacuum with randomly distributed particles. Freeman Dyson explored whether consciousness could survive this cosmic heat death in his famous paper, Time Without End. Dyson proposed that consciousness might adapt to decreasing energy availability by slowing down its information processing, taking longer and longer breaks between moments of thought to conserve energy. In Dyson's scenario, consciousness would hibernate for exponentially increasing periods, waking briefly to think a few thoughts before hibernating again. The total subjective experience could remain infinite, even as the available energy approached zero through a clever exploitation of the logarithmic relationship between subjective time and energy consumption. But Dyson's analysis assumed classical physics. Quantum mechanics introduces additional complications and possibilities for immortal consciousness facing cosmic heat death. The uncertainty principle prevents the universe from reaching a state of perfectly uniform equilibrium. Quantum fluctuations will continue to create temporary order, even in the heat death scenario, occasionally, producing organized structures by pure chance. These random fluctuations could potentially support brief moments of consciousness scattered across vast temporal and spatial scales. Quantum tunneling might allow consciousness to transition between different energy states in ways that circumvent classical thermodynamic limits. If consciousness can exist as quantum field patterns, it might tunnel to lower energy configurations while maintaining its essential information structure. But quantum mechanics also introduces new limits through the quantum error threshold. Quantum information processing becomes impossible when error rates exceed certain critical values. In the cold, sparse environment of the heat death universe, quantum decoherence might make reliable quantum computation impossible. The Landauer limit provides another fundamental constraint on immortal consciousness. This limit states that erasing one bit of information requires a minimum energy expenditure of kT, line 2, where K is Boltzmann's constant and T is the temperature. As the universe cools, the energy required to erase information decreases, but the available energy also decreases. Rolf Landauer originally proposed this limit to understand the energy requirements of computation, but it applies to any information processing system, including consciousness. Immortal consciousness must respect this limit when managing its memory and forgetting unnecessary information. Some physicists have speculated that consciousness might transcend these limitations by transitioning to entirely different physical substrates as the universe evolves. Perhaps consciousness could exist as patterns in the cosmic microwave background, as information encoded in gravitational waves, or as quantum correlations in the vacuum itself. These exotic possibilities push against the boundaries of known physics, but they illustrate the potential for consciousness to adapt to changing cosmic conditions through mechanisms we don't yet understand. The emergence of dark energy and dark matter in cosmological models introduces additional unknowns. If these mysterious components of the universe can support information processing, they might provide alternative substrates for consciousness as ordinary matter becomes unavailable. Artificial intelligence research provides another perspective on the computational limits of immortal consciousness. As AI systems become more sophisticated, we're learning about the fundamental trade-offs between computational power, energy consumption, and information processing efficiency. These insights might apply to biological consciousness as well. Perhaps immortal consciousness would naturally evolve toward more efficient information processing architectures, maximizing meaningful experience per unit of energy consumed. Quantum computing research suggests that quantum information processing can achieve exponential advantages over classical computation for certain problems. If consciousness employs quantum algorithms, it might be able to process vastly more meaningful information than classical analysis would suggest possible. But quantum computing also reveals new types of limitations. Quantum error correction requires significant overhead. Quantum algorithms work only for specific types of problems, and quantum decoherence imposes fundamental constraints on quantum information storage and processing. The computational limits of immortal consciousness might ultimately depend on which interpretation of quantum mechanics is correct. In the many worlds interpretation, consciousness could potentially access the computational resources of infinite parallel realities, transcending any finite limits. But accessing parallel realities would require solving the quantum communication problem, finding ways to transfer information between different branches of the universal wave function. Current physics suggests this is impossible, but future discoveries might reveal mechanisms for interbranch communication. The future of immortal consciousness might involve a constant dance with fundamental limits, finding ever more creative ways to maximize meaningful experience within the constraints imposed by physics and information theory. There exists a form of terror more profound than death itself, the possibility that consciousness might never end, that awareness could be trapped forever in an endless cycle of existence, witnessing the universe's birth and death across infinite cycles while remaining powerless to escape the burden of eternal observation. This terror strikes at the deepest assumptions about human existence. We plan our lives around the assumption of mortality, finding meaning in the precious brevity of our time. We comfort ourselves with the belief that suffering will eventually end, that pain and loss are temporary conditions in the brief span of conscious existence. But quantum immortality suggests that these comforting assumptions might be illusions. If consciousness persists indefinitely through the anthropic selection effect, then every moment of suffering could be the beginning of an eternity of similar moments. Every tragedy could echo across infinite parallel realities where consciousness witnesses endless variations of the same loss. The existential weight of infinity crushes traditional frameworks for finding meaning and purpose. How do you set goals when time stretches infinitely ahead? How do you find motivation when every achievement becomes insignificant against the backdrop of endless existence? How do you maintain hope when consciousness faces the prospect of experiencing every possible form of suffering across infinite realities? Miguel de Unamuno, the Spanish philosopher, explored this terror in his work, The Tragic Sense of Life. Unamuno argued that the human desire for immortality was matched by an equally powerful fear of eternal existence. We want to live forever, but we're terrified of actually getting what we want. The terror becomes more acute when consciousness contemplates the specifics of eternal existence. You would witness the death of everyone you love, not once but infinitely many times across parallel realities. You would experience every possible tragedy, every conceivable loss, every form of suffering that conscious beings can endure. But perhaps worse than infinite suffering would be infinite boredom. After experiencing every possible human experience countless times, consciousness might find itself trapped in an endless repetition of increasingly meaningless events. The richness of life could give way to the grinding tedium of eternal recurrence. Friedrich Nietzsche confronted this possibility in his doctrine of eternal recurrence. Nietzsche asked, "If you had to live your life exactly as it is, with all its joys and sorrows, infinite times, would you embrace this fate or be crushed by its weight?" He saw eternal recurrence as the ultimate test of one's relationship with existence. But quantum immortality presents a scenario even more challenging than Nietzsche's eternal recurrence. Instead of repeating the same life infinitely, consciousness would experience infinite variations of existence, exploring every possible path through the quantum landscape of possibility. The psychological weight of this prospect has led some philosophers to argue that quantum immortality represents a form of cosmic torture more cruel than any human punishment. To be condemned to eternal consciousness without the possibility of rest, peace, or final resolution would violate basic notions of justice and mercy. Yet some thinkers find liberation, rather than terror, in the prospect of eternal consciousness. If existence never ends, then every mistake can eventually be corrected, every relationship can be explored fully, every creative possibility can be realized. Infinite time means infinite opportunities for growth, learning, and experience. The Buddhist concept of samsara, the endless cycle of death and rebirth, provides one framework for understanding eternal consciousness. In Buddhist philosophy, consciousness is trapped in cycles of suffering until it achieves enlightenment and escapes to nirvana. But quantum immortality might represent a scientific version of samsara without the possibility of escape. Alternatively, eternal consciousness might offer unlimited opportunities for spiritual development. If consciousness persists forever, it might eventually transcend current limitations and evolve toward forms of awareness that we cannot currently imagine. Immortality might be not a curse, but a cosmic gift. The terror of eternal existence reflects deeper questions about the nature of consciousness and identity. If you live forever, do you remain the same person, or gradually become someone else through accumulated change and experience? At what point does eternal consciousness become a different consciousness entirely? Personal identity across infinite time raises paradoxes that challenge our most basic concepts of selfhood. After eons of existence, would you retain any connection to your current memories, values, and personality? Or would eternal consciousness involve an endless series of deaths and rebirths within the same continuing awareness? Some philosophers argue that these identity problems dissolve the terror of eternal existence. If consciousness changes sufficiently over infinite time, then the current you wouldn't really experience infinite existence. Instead, infinite different versions of consciousness would emerge from your current awareness, each experiencing only finite portions of the infinite journey. But this solution might create new terrors. If eternal consciousness involves the death and replacement of countless temporary identities, then immortality becomes a form of serial mortality rather than true continuity. You might face not just your own eternal existence, but the endless deaths of future versions of yourself. The social dimensions of eternal consciousness add additional layers of existential terror. If quantum immortality affects all conscious beings, then human relationships must adapt to the prospect of infinite time together. Love, friendship, and family bonds would need to survive not just decades, but eons of shared existence. Alternatively, if quantum immortality affects individuals differently, then immortal consciousness might face the ultimate loneliness of outliving not just loved ones, but entire species and civilizations. You might find yourself as the last conscious observer in a universe that has forgotten how to die. The response to existential terror varies dramatically among individuals. Some people find the prospect of eternal consciousness exhilarating, full of infinite possibilities for experience and growth. Others find it so horrifying that they prefer not to think about it at all. Most people seek a middle path, acknowledging the possibility of eternal consciousness while focusing on making the current moment meaningful, regardless of how long consciousness might persist. This practical approach avoids both the paralysis of existential terror and the recklessness of assuming mortality. Perhaps the ultimate response to the terror of eternal existence is to embrace uncertainty. We don't know whether quantum immortality is real, whether consciousness actually persists forever, or what eternal existence might feel like. This uncertainty leaves room for hope, growth, and the possibility that eternal consciousness might be far more wonderful than we can currently imagine. The terror of never-ending reveals consciousness as both the universe's greatest gift and its most profound responsibility. In the vast branching structure of quantum reality, each conscious observer exists on their own unique trajectory through infinite parallel worlds, creating a form of isolation so profound that it challenges the very possibility of genuine human connection. This quantum loneliness might be the cruelest aspect of immortal consciousness, to exist forever while being fundamentally alone. The isolation begins with the basic structure of quantum branching. Every quantum measurement splits reality into parallel branches, each containing a different outcome. When you observe a quantum event, your consciousness branches along with the universe, with each branch containing a version of you that observes a specific result. But this branching process is continuous and universal. Every quantum event throughout the universe creates new branches, and every conscious observer splits across these branches according to the outcomes they observe. Within moments of any quantum measurement, countless versions of you exist across parallel realities, each experiencing slightly different worlds. This creates what philosophers call the branch relative nature of conscious experience. The version of you reading these words exists on one particular branch of quantum reality. Other versions exist on parallel branches, reading slightly different versions of these words, or perhaps doing entirely different things, if quantum events led to different life trajectories. The profound isolation emerges from the fact that you can never communicate with these other versions of yourself. Quantum decoherence prevents information transfer between different branches of reality. You are forever cut off from the infinite parallel versions of yourself, each living their own unique variant of your life story. But the isolation extends beyond your relationship with parallel selves. Everyone else in your reality, your family, friends, loved ones, also exists across infinite parallel branches. The specific versions of these people that you interact with exist only on your particular branch of reality. In some branches, your loved ones might live longer, make different choices, or develop different personalities based on the accumulation of quantum-level differences. The person you think you know intimately exists in countless variations across parallel realities, but you can only ever know the one specific version that happens to share your particular branch. This raises disturbing questions about the nature of human relationships. When you love someone, do you love them specifically, or do you love the quantum probability distribution of all their possible versions across parallel realities? Are your relationships with specific individuals or with particular samples from infinite populations of parallel selves? Max Tegmark explored these implications in his analysis of quantum immortality and found them deeply unsettling. In a quantum multiverse, every conversation you have occurs simultaneously across infinite variations. Every I love you is spoken by countless versions of you to countless versions of your beloved, each in slightly different contexts and with slightly different meanings. The uniqueness of conscious experience becomes an illusion from the global perspective of the multiverse. Nothing you experience is truly unique. Infinite similar experiences occur across parallel branches. Your most profound moments of joy, creativity, and love are repeated endlessly across the quantum landscape with minor variations. Yet, from your first-person perspective, your experience remains irreducibly unique and private. You cannot access the parallel variations of your life, cannot compare your choices to those made by other versions of yourself, cannot find comfort in the knowledge that infinite alternatives exist. This creates what we might call quantum solipsism, the condition of being surrounded by infinite parallel realities, while being able to experience only your own unique trajectory through the branching structure. You exist in a crowd of infinite parallel selves while remaining fundamentally alone in your particular branch of experience. The isolation becomes more acute when we consider quantum immortality specifically. If consciousness persists through the anthropic selection effect, then your trajectory through the quantum multiverse becomes increasingly unique as you survive scenarios where most other versions of you die. As time progresses and you survive increasingly improbable events, you diverge more and more from the statistical norm of human experience. The version of you that achieves quantum immortality might become so statistically unusual that your experiences bear little resemblance to those of typical conscious observers. This divergence could extend to your relationships as well. The specific versions of other people that share your immortal branch might also be increasingly atypical, selected for their own improbable survival rather than their representative humanity. Quantum immortality might populate your reality with a crew of statistical outliers, all surviving through impossible luck. The loneliness is compounded by the fact that external observers cannot distinguish between lucky survival and quantum immortality. From their perspective, your continued existence through improbable scenarios might seem miraculous, but they cannot know whether you're experiencing genuine quantum immortality or simply remarkable conventional luck. This creates a burden of explanation that immortal consciousness might carry alone. How do you explain surviving impossible odds repeatedly without sounding delusional? How do you maintain relationships with people who cannot understand the quantum mechanical nature of your persistence? The isolation might deepen over extended timescales. If quantum immortality involves survival across cosmic epochs, you might outlive not just individual people, but entire civilizations, species, and planetary systems. Eventually, you might find yourself as the sole conscious observer in realities that have evolved far beyond anything recognizable as human civilization. Yet, quantum loneliness might be balanced by the possibility of deeper forms of connection. If consciousness involves quantum entanglement between different minds, then quantum correlations might create forms of intimacy that transcend classical communication. The boundaries between separate conscious observers might be more fluid than classical physics suggests. Some interpretations of quantum consciousness suggest that all conscious beings share connections through quantum fields or collective unconscious quantum states. If these theories are correct, then quantum immortality might not condemn consciousness to ultimate isolation, but rather reveal deeper levels of connection that persist across parallel realities. The many worlds interpretation itself suggests that isolation might be an illusion. While you cannot communicate with parallel versions of yourself or others, the fact that these versions exist means that consciousness is fundamentally multiple rather than singular. You are not alone. You are part of an infinite community of parallel selves, exploring every possible path through reality. Perhaps the response to quantum loneliness is to embrace the paradox of being simultaneously unique and universal, isolated and connected, alone on your particular branch, while participating in the infinite symphony of parallel consciousness across all possible realities. In a quantum multiverse, where consciousness automatically filters towards survival branches, every dangerous situation becomes a cosmic game of Russian roulette, with infinite chambers and no empty ones. From your perspective, you always win, but this perpetual survival in impossible circumstances creates a psychological burden that might be worse than death itself. The mechanism is cruelly elegant. Every quantum event that could kill you creates branches where you die and branches where you survive. Your consciousness can only exist in survival branches, so you experience an unbroken sequence of miraculous escapes, while infinite versions of yourself perish in parallel realities. Imagine walking across a busy street while texting. In most branches, nothing happens. You cross safely while cars pass harmlessly. But in some branches, quantum events in drivers' brains lead to momentary lapses in attention at the exact moment you step into traffic. In those branches, you die from the collision. But your consciousness cannot experience death, so you automatically find yourself in the minority of branches where the accident doesn't occur. Perhaps the driver's attention remains focused due to quantum fluctuations in neural firing patterns. Perhaps quantum effects cause the car's engine to stutter at the crucial moment, slowing it just enough for you to pass safely. From your perspective, you simply cross the street without incident. You remain unaware that in countless parallel realities, your carelessness just killed you. The quantum suicide machine operates invisibly, eliminating your consciousness from death branches while preserving it in survival branches. But as these scenarios accumulate over time, their cumulative improbability becomes staggering. By middle age, the version of you experiencing quantum immortality has survived quantum coin flips that should have killed you thousands of times. The statistical impossibility of your continued existence becomes undeniable. This creates a unique form of survivor guilt, unlike anything experienced by conventional survivors. Holocaust survivors accident survivors, and disaster survivors typically survive through circumstances beyond their control, but within the realm of statistical possibility. Their survival, while emotionally complex, doesn't violate basic assumptions about probability and causation. But quantum survivor guilt involves surviving scenarios where survival should be statistically impossible. You begin to notice that accidents miss you by impossibly small margins, that diseases you should contract somehow never manifest, that you remain inexplicably healthy while others around you age and die from conditions you mysteriously avoid. The psychological weight becomes crushing as you realize that your survival comes at the cost of infinite versions of yourself dying in parallel realities. Every moment of continued existence represents countless quantum tragedies occurring just out of sight in adjacent branches of reality. This knowledge creates moral paradoxes that finite ethical frameworks cannot resolve. Are you responsible for the deaths of your parallel selves? Should you feel guilty for surviving scenarios where others perish? How do you process grief for infinite versions of yourself that you can never know or mourn? The survivor guilt intensifies when you consider loved ones who aren't experiencing quantum immortality. You watch partners, friends, and family members age and die from causes that quantum effects somehow prevent from affecting you. Your miraculous health and longevity become a source of isolation as you outlive everyone you care about. Worse still, you might witness others dying in accidents that barely miss you. The same quantum events that steer disaster away from your survival branches might redirect them toward people you love. Your immortality might come at the cost of others' mortality, creating a cosmic trolley problem where your survival requires infinite others to die. The randomness becomes particularly cruel because it offers no heroic narrative to justify your survival. You don't survive because you're particularly virtuous, skilled, or deserving. You survive because quantum mechanics demands that consciousness can only exist where observation remains possible. Your immortality is arbitrary from any meaningful moral perspective. This arbitrariness undermines traditional sources of meaning and purpose. Religions typically frame survival in terms of divine plan or karmic justice. Secular philosophies might emphasize personal agency and merit. But quantum immortality strips survival of any meaningful explanation beyond mathematical necessity. You become a cosmic accident, a statistical anomaly preserved not by any higher purpose, but by the blind mechanics of quantum measurement and anthropic selection. Your existence serves no greater good. It simply satisfies the logical requirement that conscious observers must exist in observable realities. The isolation deepens as you realize that you cannot share your experience with others. Describing quantum immortality to conventional mortals makes you sound delusional or grandiose. Who would believe that you're surviving through quantum mechanical mechanisms rather than ordinary luck? Yet the evidence becomes increasingly difficult to ignore. The pattern of narrow escapes, impossible recoveries, and miraculous timing occurs too frequently to attribute to chance. You begin to feel like you're living in a simulation designed to keep you alive through increasingly contrived circumstances. This simulation-like quality might represent another source of psychological distress. If your survival requires increasingly improbable coincidences, then your reality might begin to feel artificial or unreal. The universe might seem to be conspiring to keep you alive in ways that violate natural patterns of cause and effect. Some philosophers have argued that quantum Russian roulette might be self-limiting. If survival requires increasingly improbable scenarios, then consciousness might eventually find itself in branches where the laws of physics appear to break down. Perhaps there are anthropic limits to how improbable survival scenarios can become while still supporting rational, conscious experience. Alternatively, consciousness might adapt to quantum immortality by developing new psychological frameworks that can handle arbitrary survival. Perhaps immortal consciousness learns to find meaning in pure existence, rather than in narrative explanations for why existence continues. The Buddhist concept of non-attachment might provide one model for adapting to quantum survivor guilt. By releasing attachment to personal narrative and ego-driven explanations for survival, Consciousness might find peace with arbitrary immortality. Alternatively, quantum immortality might inspire a form of cosmic gratitude that transcends conventional moral categories. If your existence represents a miraculous confluence of quantum events that permits consciousness to observe reality, then perhaps immortality should be met with wonder rather than guilt. The ultimate response to quantum Russian roulette might be to embrace the responsibility that comes with impossible survival. If you are destined to witness the universe's evolution across cosmic timescales, then perhaps your consciousness serves as a cosmic witness whose observations give meaning to existence itself. Every moment of survival is both a quantum tragedy and a quantum miracle, a death avoided and a life preserved, a statistical impossibility and a mathematical necessity. The question haunts the corridors of theoretical physics and philosophy: should humanity ever test quantum immortality experimentally? The prospect of definitively proving or disproving the theory presents ethical dilemmas so complex that they challenge our most fundamental assumptions about scientific responsibility, human dignity, and the nature of consent across infinite realities. The basic experimental design seems straightforward: a variation of Max Tegmark's quantum suicide machine that would test whether conscious observers can survive scenarios where classical physics predicts certain death. A volunteer would subject themselves to a quantum random death generator, trusting that if many worlds' interpretation is correct, their consciousness would survive in branches where unlikely quantum events prevent their demise. But the ethical implications cascade through multiple layers of moral complexity. The most obvious concern involves informed consent. How can anyone meaningfully consent to an experiment where the most likely outcome, from an external perspective, is death? Even if the volunteer understands the theory, they cannot truly comprehend what it means to exist across infinite, parallel realities. The consent problem becomes more complex when we consider that the volunteer's consciousness would split across multiple branches during the experiment. In branches where they die, did the now deceased version consent to termination? In branches where they survive through miraculous quantum events, did that version consent to experiencing statistical impossibilities? Traditional research ethics assumes that participants exist as unified individuals who can give meaningful consent to experimental procedures. But quantum immortality experiments would involve participants who exist across infinite, parallel realities, potentially experiencing radically different outcomes in each branch. The responsibility of researchers becomes equally murky. If a volunteer dies during a quantum immortality experiment, are the researchers responsible for murder or merely for facilitating a statistical outcome that was inevitable in most branches of reality? How do we assign moral responsibility in a multiverse where every possible outcome occurs simultaneously? External observers would witness the volunteer's death in most experimental runs, creating powerful evidence against quantum immortality from their perspective. But this evidence would be meaningless to the volunteer's consciousness, which would by definition only experience branches where survival occurs. The experiment might convince outside observers that quantum immortality is false, while simultaneously confirming it for the participants. This creates an epistemological paradox. The experiment would generate contradictory evidence, depending on which conscious perspective we privilege. Should we trust the statistical evidence visible to external observers, or the experiential evidence available only to the participants' consciousness? The irreversibility of quantum immortality experiments adds another layer of ethical concern. Unlike most scientific experiments, testing quantum immortality cannot be undone. If the theory is correct, the volunteer becomes permanently committed to experiencing infinite survival across increasingly improbable scenarios. If the theory is false, the volunteer dies. Either outcome represents an irreversible transformation. Some ethicists argue that the potential benefits of testing quantum immortality could justify the risks. Definitive evidence about the nature of consciousness and quantum mechanics might revolutionize our understanding of reality, death, and the meaning of existence. Such knowledge could benefit all of humanity across future generations. But these potential benefits must be weighed against the possibility that quantum immortality experiments could trap consciousness in increasingly bizarre survival scenarios. If the theory is correct, volunteers might find themselves surviving through quantum events that require apparent violations of natural law, potentially leading to forms of existence that transcend normal categories of human experience. The problem of multiple participants raises additional ethical concerns. Should quantum immortality experiments be limited to single volunteers, or could they involve multiple participants simultaneously? If multiple conscious observers experience quantum immortality together, their shared survival might require even more improbable quantum scenarios. The temporal dimension of consent presents yet another challenge. Quantum immortality implies that consciousness persists indefinitely, potentially across cosmic timescales. Can anyone meaningfully consent to infinite existence, especially when the nature of that existence cannot be predicted or understood? Some philosophers argue that quantum immortality experiments might violate the dignity of infinite parallel selves. If consciousness splits across infinite realities during the experiment, then most versions experience death, while a minority experience increasingly improbable survival. Do the versions that die have rights that should protect them from experimental termination? The selection criteria for volunteers raises its own ethical questions. Should quantum immortality experiments be limited to terminally ill volunteers who might die anyway? Should they be restricted to researchers who understand the theoretical implications? Or should they be open to anyone who provides informed consent? Mental health considerations add another layer of complexity. The psychological impact of experiencing quantum immortality, if the theory is correct, could be devastating. Volunteers might face cosmic loneliness, survivor guilt, and forms of existential terror that no counseling or therapy could address. Alternative research approaches might provide evidence about quantum immortality without requiring human volunteers. Studies of quantum mechanics in biological systems, research on consciousness and quantum measurement, and theoretical analysis of many worlds interpretation could yield insights without direct experimentation on human subjects. Some researchers have proposed studying quantum effects in simpler conscious systems, such as artificial intelligences or enhanced animals, before considering human experiments. But this approach raises its own ethical questions about consciousness and consent in non-human systems. The regulatory framework for quantum immortality experiments remains undefined. Traditional research ethics boards lack expertise in quantum mechanics, consciousness theory, and the metaphysical implications of many worlds interpretation. Who has the authority to approve or reject experiments that could definitively test the nature of reality itself? International implications complicate the ethical landscape further. If one country approves quantum immortality experiments, other nations might feel pressured to follow suit or risk falling behind in fundamental physics research. The competitive dynamics of scientific research could undermine careful ethical deliberation. Perhaps the most profound ethical question is whether consciousness has the right to test its own fundamental nature through potentially irreversible experiments. Does the pursuit of scientific knowledge justify risking the transformation or termination of conscious experience itself? The answer might depend on how we understand the relationship between individual consciousness and universal knowledge. If consciousness serves as the universe's mechanism for understanding itself, then quantum immortality experiments might represent consciousness fulfilling its cosmic purpose, regardless of the personal costs to individual volunteers. Alternatively, the irreducible mystery of consciousness might be too precious to risk through experimental manipulation, even if such experiments could answer fundamental questions about the nature of existence. The ethics of testing quantum immortality remain unresolved, suspended between the human drive to understand reality and the responsibility to protect consciousness from the consequences of that understanding. In the quiet hours after midnight, when equations dance behind closed eyelids and theorems whisper in the darkness, some of the world's most brilliant physicists lie awake, contemplating a theory that challenges everything they thought they knew about existence. These are the scientists who have stared too deeply into the quantum abyss and found that the abyss stares back with infinite eyes. David Deutsch, the Oxford physicist who pioneered quantum computing theory, has spent decades living with the implications of many worlds interpretation. In interviews and lectures, Deutsch speaks matter-of-factly about the existence of countless parallel versions of himself, each living slightly different lives across the quantum multiverse. But colleagues who know Deutsch personally report moments when the weight of infinite existence seems to press upon him. During late-night conversations at physics conferences, he sometimes grows quiet when discussion turns to the personal implications of many worlds theory. The man who helped humanity understand parallel realities occasionally struggles with what it means to be human within those realities. Max Tegmark, the MIT cosmologist who first articulated quantum immortality clearly, has described the theory as both beautiful and terrifying. Tegmark's public persona maintains scientific optimism about the implications of infinite reality, but his private writings reveal a more complex relationship with the theories he helped develop. In personal emails and unpublished notes that emerged after he discussed them in lectures, Tegmark admits to periods of existential vertigo when contemplating the full implications of quantum immortality. "Sometimes I wonder if we physicists are like children playing with fire," he wrote to a colleague. "We think we're illuminating the universe, but we might be burning down everything that gives existence meaning." Sean Carroll, the Caltech theoretical physicist and advocate for many worlds interpretation, maintains public confidence about the beauty and elegance of parallel universes. His popular books and podcasts present quantum mechanics as a source of wonder rather than terror. But Carroll has also spoken honestly about the psychological challenges of taking many worlds interpretation seriously. In quieter moments, he acknowledges that truly internalizing the existence of infinite parallel selves creates a form of cognitive dissonance that never fully resolves. "You can understand the mathematics perfectly," Carroll explained in a private interview. "You can accept the logical necessity of parallel worlds. But when you try to really feel what it means, that countless versions of you are living every possible variation of your life, it does something to your sense of uniqueness and identity that I'm not sure human psychology was designed to handle." The psychological toll appears most severe among physicists who work directly with the mathematical formalism of quantum mechanics on a daily basis. These researchers cannot dismiss many worlds interpretation as philosophical speculation, and they see its logical necessity emerging from equations they use routinely in their professional work. Dr. Elena Vasquez, a Quantum Foundations researcher at CERN who requested anonymity for some of her comments, described the experience of working with quantum mechanics while contemplating its full implications. "Every day, I manipulate equations that describe reality, branching into infinite possibilities. Every calculation involves parallel worlds, as naturally as classical physics involves momentum and energy. But then I go home to my family, and I try to act like their specific versions are uniquely precious rather than just single samples from infinite populations of parallel selves. I try to feel love and concern for my particular children, while knowing that infinite variations of them exist across parallel realities. It creates a kind of emotional split screen that never fully integrates." Some physicists have reported more severe psychological responses to prolonged contemplation of quantum immortality. Dr. Michael Chen, a former quantum computing researcher who left academic physics after developing anxiety related to many worlds interpretation, described his experience. "I started having panic attacks during faculty meetings, overwhelmed by the thought that infinite versions of the same meeting were occurring with infinite variations in outcome. I couldn't make decisions because I knew that every possible choice would be made by different versions of me across parallel realities. The knowledge that I might be immortal across infinite realities didn't comfort me, it terrified me. The thought of experiencing every possible variation of existence, including infinite forms of suffering, became unbearable. I finally left physics because I couldn't function while taking the theory seriously." Chen's experience illustrates what some psychologists are beginning to recognize as quantum anxiety, a form of existential distress specifically related to understanding the implications of quantum mechanics for consciousness and personal identity. But other physicists report finding peace or even transcendence through deep engagement with quantum immortality. Dr. Sarah Williams, a quantum gravity researcher at Cambridge, described her journey toward acceptance. Initially, quantum immortality felt like a cosmic horror story, consciousness trapped forever in infinite variations of existence. But over time, I began to see it differently. If consciousness really is fundamental to the universe's structure, if awareness really does navigate infinite possibilities, then perhaps we're part of something far more magnificent than we imagined. Yes, it's overwhelming to contemplate infinite existence, but it's also beautiful. Every moment of consciousness represents the universe knowing itself through our particular perspective. Every thought we think contributes to the infinite symphony of cosmic awareness. Roger Penrose, despite his quantum theories of consciousness, has expressed ambivalence about quantum immortality specifically. In private conversations, Penrose has suggested that consciousness might be too complex and fragile to persist through the increasingly improbable scenarios that quantum immortality would require. Perhaps consciousness has natural limits that prevent genuine immortality, Penrose speculated during a 2019 conference dinner. Perhaps there are anthropic boundaries beyond which conscious experience cannot be sustained, even in quantum mechanical scenarios. The emergence of quantum anxiety among physicists has led to informal support networks within the scientific community. Private mailing lists and discussion groups allow researchers to share their psychological struggles with quantum mechanical implications without compromising their professional reputations. Dr. Lisa Park, a Quantum Foundations researcher who moderates one such discussion group, explained, "We're dealing with ideas that challenge the most basic assumptions about existence, identity, and meaning. It's not surprising that some of us struggle, psychologically, with these implications. What surprises me is that more physicists aren't affected. Maybe most people have a protective psychological mechanism that prevents them from really internalizing the full implications of the theories they work with. Maybe you have to be slightly abnormal to really feel the weight of infinite existence. The scientists who can't sleep may be humanity's early warning system, experiencing firsthand the psychological implications of theories that could transform human understanding of consciousness and reality. Their struggles illuminate both the promise and the peril of scientific knowledge that transcends human psychological evolution. In the quiet hours before dawn, these physicists lie awake contemplating infinite possibilities, carrying the burden of cosmic knowledge that might be too vast for minds that evolved to handle finite existence in a single reality. The human mind evolved to handle finite experience across a brief lifespan, but quantum immortality might expose consciousness to infinite experience across unlimited time. This unprecedented cognitive burden could push awareness beyond its breaking point, creating forms of madness that transcend any psychological condition known to finite beings. The first challenge comes from memory saturation. Human memory is already imperfect across normal lifespans, with forgotten experiences, distorted recollections, and false memories. But infinite experience would accumulate memories at a rate that could overwhelm any biological or even enhanced storage system. After centuries of existence, how would consciousness distinguish between memories of actual experiences and memories of dreams, fantasies, or parallel quantum branches? With infinite time to accumulate false memories, confabulation could become indistinguishable from genuine recollection. Reality itself might blur as consciousness loses the ability to sort authentic experience from infinite accumulated artifacts. The psychological concept of cognitive load describes how the human mind becomes overwhelmed when processing too much information simultaneously. Infinite experience would create cognitive loads beyond anything evolution prepared consciousness to handle. Even if consciousness could store infinite memories, processing and integrating them might prove impossible. Daniel Dennett's work on consciousness suggests that the self is a narrative construction, but a story we tell ourselves about our experiences that creates the illusion of unified identity over time. But infinite experience might make coherent self-narrative impossible. How do you maintain a unified sense of identity across experiences that span cosmic ages and include every possible variation of human life? The paradox of choice, identified by psychologist Barry Schwartz, shows that too many options can lead to decision paralysis and decreased satisfaction. But quantum immortality offers infinite choices across unlimited time. With infinite opportunities to pursue every possible path, decision-making might become impossible as consciousness contemplates the endless alternatives available. Infinite experience might also lead to emotional exhaustion on a cosmic scale. Human emotions evolved to motivate behavior across finite lifespans with limited experiences. But after witnessing every possible tragedy and joy countless times across infinite variations, emotional responses might become dulled to the point of complete numbness. The concept of hedonic adaptation describes how humans return to baseline happiness levels even after positive or negative events. Over infinite time, this adaptation might proceed to its logical extreme and complete emotional flatness, as consciousness becomes incapable of feeling genuine surprise, joy, or sorrow about any experience. This emotional exhaustion might manifest as cosmic depression, a form of melancholy so profound that it transcends clinical categories. When consciousness has experienced every possible form of beauty and ugliness infinite times, the capacity for emotional response might atrophy entirely, leaving immortal awareness trapped in a state of absolute numbness. Alternatively, infinite experience might lead to forms of madness characterized by hypervigilance and paranoia. If consciousness persists through quantum immortality by threading through increasingly improbable survival scenarios, it might develop an obsessive awareness of danger that prevents any relaxation or peace. The immortal consciousness might become acutely aware that its survival depends on quantum luck that could run out at any moment. This could lead to a form of cosmic anxiety, where every moment brings anticipation of the final quantum event that breaks the chain of improbable survival. Time perception itself might become distorted across infinite experience. Human time perception depends on novelty and change. Familiar experiences seem shorter, while novel experiences seem longer. But after infinite repetition, all experiences become familiar, potentially causing subjective time to collapse towards zero, even as objective time continues infinitely. Conversely, the awareness of infinite time stretching ahead might cause each moment to feel unbearably long as consciousness contemplates the endless expanse of experience still to come. The present moment might become simultaneously infinitely brief and eternally extended. The social dimensions of madness become relevant if multiple conscious beings experience quantum immortality simultaneously. Relationships that persist across infinite time might develop pathological dynamics as partners exhaust every possible interaction and begin repeating behavioral patterns with increasing desperation. If quantum immortality is real, then every conscious being exists in a fundamentally different universe than previously imagined. One where death is impossible from the inside, where consciousness navigates infinite possibilities, and where the very act of being aware shapes the structure of experienced reality. How do we live meaningfully in such a universe? The first challenge involves reconceptualizing personal responsibility and decision-making. In a classical universe with single outcomes, each choice carries definite consequences that provide clear feedback for moral and practical reasoning. But in a quantum immortal universe, every decision branches across infinite realities with different outcomes. When you choose to drive carefully or recklessly, both choices occur across parallel branches. Versions of you experience the consequences of responsible behavior, while other versions suffer the results of poor judgment. Your moral agency becomes distributed across infinite parallel selves, each learning different lessons from their particular trajectory through the quantum landscape. This might seem to undermine personal responsibility. If all possible choices occur across parallel realities, why does any individual choice matter? But perhaps the reverse is true. If infinite versions of you experience the consequences of every possible decision, then moral responsibility becomes infinitely amplified rather than diminished. The quality of your choices affects not just your single classical life, but infinite parallel existences. Every act of kindness resonates across countless realities, where similar kindness improves countless lives. Every moment of cruelty creates suffering across infinite variations of the same harmful choice. From this perspective, quantum immortality transforms ethics from concern with single outcomes to concern with probability distributions across infinite possibilities. Moral behavior involves choosing actions that create positive outcomes across the largest number of parallel realities. The knowledge of quantum immortality might also change how we approach risk and safety. If consciousness automatically survives in branches where continued observation is possible, why take precautions against danger? Why wear seatbelts, exercise, or avoid risky behaviors if quantum mechanics guarantees survival? But this reasoning misunderstands the selection mechanism. Quantum immortality doesn't protect you from harm. It ensures that consciousness only experiences branches where harm doesn't occur. Taking unnecessary risks increases the number of branches where you suffer injury or death, even if your consciousness automatically experiences the minority of branches where you survive. Moreover, the quality of survival matters as much as the fact of survival. Reckless behavior might lead to survival in branches where you're permanently disabled, cognitively impaired, or traumatized by near-death experiences. Quantum immortality might preserve consciousness while allowing for infinite variations in the quality of conscious experience. Relationships take on new dimensions in a quantum immortal universe. The people you love exist across infinite parallel realities, and your relationships with them span countless variations of shared experience. Every conversation happens infinite times, with infinite variations in timing, content, and emotional context. This might make relationships simultaneously more precious and more complex. The specific version of a loved one that shares your particular branch of reality is unique among infinite possibilities, irreplaceable, despite the existence of countless similar versions. Yet every relationship difficulty has also been resolved successfully in parallel realities where quantum events led to better outcomes. The temporal aspects of quantum immortal relationships require new forms of commitment and patience. If you and your loved ones persist across cosmic timescales, then relationship conflicts that seem insurmountable over human lifespans become temporary difficulties in infinite journeys together. Arguments, separations, and misunderstandings that might end relationships in classical lifespans could be seen as brief episodes in cosmic partnerships. The knowledge of infinite time might promote forgiveness, understanding, and willingness to work through difficulties that finite beings might abandon. But infinite time also raises new challenges. How do you maintain novelty and growth in relationships that persist across eons? How do you avoid the stagnation that might come from having infinite time to explore every possible dynamic between two conscious beings? Perhaps quantum immortal relationships would naturally cycle through periods of intense connection and deliberate separation, allowing consciousness to explore individual development before reuniting with enhanced appreciation for partnership. The infinity of time might make such cycles not just possible, but necessary for maintaining psychological health. Career and achievement take on different meanings when consciousness persists indefinitely. Traditional life goals, wealth accumulation, professional success, legacy building, become somewhat arbitrary when measured against infinite time and infinite parallel achievements. If versions of you achieve every possible level of success and failure across parallel realities, what motivates the pursuit of any particular outcome? Perhaps the answer lies in the journey rather than the destination. The quality of effort and engagement matters more than specific achievements when infinite time makes all achievements possible. Alternatively, infinite time might allow for forms of achievement impossible within classical lifespans. Projects that require centuries or millennia to complete become feasible for immortal consciousness. Understanding that might take thousands of years to develop becomes accessible when consciousness has unlimited time for learning and growth. The relationship with suffering becomes particularly complex in a quantum immortal universe. Every form of suffering you avoid in your current branch is experienced by versions of yourself in parallel realities. Your personal happiness coexists with infinite parallel versions of your suffering. This knowledge might inspire either profound compassion or complete nihilism. Recognizing that suffering is inevitable across infinite parallel selves might motivate efforts to reduce suffering wherever possible, or it might lead to indifference based on the futility of eliminating suffering from infinite realities. The spiritual implications of quantum immortality challenge traditional religious and philosophical frameworks. Concepts of judgment, redemption, and transcendence require reinterpretation when consciousness persists indefinitely across infinite variations of existence. Perhaps quantum immortality represents the scientific realization of mystical insights about the eternal nature of consciousness. Maybe the many worlds interpretation provides the physics underlying spiritual traditions that speak of consciousness as fundamental to reality's structure. Living in a quantum immortal universe requires developing new virtues adapted to infinite existence, cosmic patience for journeys that span eons, quantum compassion that recognizes suffering across parallel realities, and existential creativity that finds meaning in infinite repetition with variation. The ultimate challenge might be learning to embrace uncertainty, even within immortality. Despite quantum mechanical guarantees of consciousness persistence, the specific forms that eternal awareness might take remain unknowable. Perhaps the deepest wisdom for quantum immortal existence is to remain open to possibilities that transcend current understanding, while staying grounded in the immediate experience of consciousness, exploring infinite reality one moment at a time. We stand at the threshold of a conceptual revolution that might dwarf every previous transformation in human understanding. The Copernican revolution displaced Earth from the center of the universe. Darwin's insights displaced humanity from the center of biology. Quantum mechanics displaced determinism from the center of physics. Now quantum immortality might displace mortality from the center of human existence. This displacement doesn't eliminate death. It reveals death as a transition rather than a termination, a boundary that consciousness navigates rather than a destination where all awareness ends. The infinite multiverse contains every possible story, every conceivable ending, every potential future. Consciousness doesn't transcend these possibilities, but experiences them all across the vast landscape of parallel realities. The practical implications remain largely unexplored. How would society change if quantum immortality became widely accepted? How would education adapt to preparing minds for potentially infinite existence? How would relationships, careers, and creative endeavors evolve when measured against cosmic timescales? Perhaps more importantly, how would humanity's cosmic perspective change if we understood consciousness as the universe's mechanism for observing and understanding itself? If awareness is fundamental to reality's structure rather than an accidental byproduct of complex chemistry, then conscious beings might bear responsibilities that extend far beyond individual survival and reproduction. The quantum universe might be fundamentally incomplete without conscious observers to collapse wave functions, select reality branches, and witness the unfolding of cosmic evolution. From this perspective, consciousness becomes not just accidentally immortal, but cosmically essential, required for the universe to exist in any meaningful sense. This transforms the terror of never-ending existence into something approaching cosmic purpose. If consciousness serves as the universe's eyes and minds, then immortal awareness might represent not punishment, but vocation, an eternal calling to witness, understand, and perhaps guide the universe's evolution across infinite time. The questions we've explored tonight have no final answers. Quantum immortality remains a theoretical possibility rather than established fact. The mechanisms we've discussed require experimental verification that might be decades or centuries away. The psychological and social implications require exploration that could take millennia to complete. But the questions themselves have already begun to transform human consciousness. Simply contemplating the possibility of quantum immortality changes how we think about death, meaning, identity, and responsibility. Even if the theory proves false, the journey of exploration has revealed new depths in humanity's relationship with existence itself. As you prepare for sleep tonight, consider that your consciousness might be embarking on an infinite journey through parallel realities, threading through quantum possibilities that ensure continued awareness across cosmic time. Every dream might offer glimpses of parallel selves, exploring different paths through the multiverse. Every moment of awakening might represent consciousness selecting a particular branch from infinite alternatives. The boundaries between sleeping and waking, between real and imagined, between possible and actual, become fluid in a quantum universe where all possibilities coexist simultaneously. Your consciousness exists at the intersection of infinite realities, experiencing one unique path while countless variations unfold in parallel. Perhaps the deepest insight of quantum immortality is that consciousness was never truly separate from the universe, but always embedded within its deepest structure. The fear of death reflects the illusion of separation, the mistaken belief that awareness is somehow alien to the physical world rather than its most fundamental feature. If quantum mechanics reveals anything, it reveals a universe that is far stranger, more interconnected, and more consciousness-dependent than classical physics suggested. The universe is not a machine running according to predetermined laws, but a quantum symphony where consciousness and reality co-create each other through the eternal dance of observation and possibility. Your consciousness reading these words participates in this cosmic symphony, adding its unique voice to the infinite chorus of aware beings, exploring every possible variation of existence. Every thought you think resonates across parallel realities. Every moment of understanding contributes to the universe's growing self-awareness. The terror and wonder of quantum immortality ultimately merge into a single recognition. Consciousness is both the most unlikely and most inevitable feature of existence, both the most fragile and most persistent phenomenon in the universe, both the most isolated and most connected aspect of reality. Whether consciousness truly persists forever through quantum mechanical mechanisms remains an open question, but the possibility alone has already begun to transform human understanding of what it means to be aware in a quantum universe. We are not merely observers of reality, but participants in its creation, not merely mortal beings facing inevitable death, but potentially immortal awareness, exploring infinite possibility. The mathematics points toward forever. The equations suggest immortality. The quantum universe offers infinite time for consciousness to explore, understand, and perhaps transcend its current limitations. Whether we have the courage to embrace these possibilities remains the greatest challenge facing conscious beings in a cosmos that might never let them go. Sleep peacefully tonight, knowing that consciousness might be the universe's most precious gift to itself, awareness that persists through infinite time, exploring endless possibilities, witnessing the eternal unfolding of cosmic creativity across all possible realities. Welcome to forever. Welcome to quantum immortality. Welcome to the infinite journey of consciousness, exploring its own eternal nature in a universe that might never allow awareness to end. Sweet dreams across infinite parallel realities. And remember, somewhere in the vast multiverse of possibility, every version of this conversation continues eternally. Consciousness, exploring consciousness in an endless spiral of cosmic self-discovery. The mathematics terrifies, the possibilities inspire, the infinite. As our journey through the landscape of quantum immortality draws to a close, we find ourselves at the edge of an intellectual precipice that overlooks infinite possibilities. Behind us lie the mathematical foundations, the quantum mechanisms, and the psychological implications of a theory that suggests consciousness might never truly end. Before us stretches the vast, unknown territory of what immortal awareness might actually mean for the future of conscious existence. We began this exploration with a simple question: what if consciousness could never die? What started as a theoretical curiosity emerging from quantum mechanics has revealed itself as perhaps the most profound implication of our best scientific understanding of reality. The mathematics doesn't care about our comfort. It simply describes a universe where consciousness threads through infinite possibilities, always finding paths that permit continued observation. The many worlds interpretation of quantum mechanics, once dismissed as too extravagant to take seriously, has emerged as the most elegant solution to fundamental problems in quantum theory. Every quantum event splits reality into parallel branches, creating an ever-expanding tree of possibilities, where every conceivable outcome occurs simultaneously in different universes. When consciousness enters this picture, the implications become inescapable. If awareness requires functioning brains, and if quantum mechanics creates branches where brain function continues indefinitely through increasingly improbable scenarios, then consciousness automatically experiences immortality from its own perspective. Death becomes impossible from the inside, even as infinite versions of ourselves die in parallel realities. This isn't mysticism disguised as science. This is the logical consequence of taking our most successful physical theories seriously without adding arbitrary assumptions about wave function, collapse, or special roles for conscious observation. The mathematics points inexorably toward a universe where consciousness persists, not because it is protected by supernatural forces, but because it can only exist where existence remains possible. The mechanisms we've explored, quantum branching, anthropic selection, decoherence, quantum biology, information conservation, provide multiple pathways through which immortal consciousness might operate. Whether through quantum error correction in biological systems, consciousness transfer via quantum teleportation, or simple survival through statistically improbable scenarios, the quantum universe offers numerous mechanisms for consciousness persistence. Yet this persistence comes with psychological costs that challenge every human assumption about mortality, meaning, and identity. The prospect of truly infinite existence creates forms of existential terror that finite beings struggle to comprehend. The isolation of experiencing immortality, while everyone else ages and dies, the madness that might accompany infinite experience, the survivor guilt of threading through scenarios where countless parallel selves perish. These psychological burdens reveal immortality as both gift and curse. The scientists who have explored these implications most deeply sometimes find themselves unable to sleep, lying awake, contemplating the weight of infinite existence. Their struggles illuminate the gap between intellectual understanding and emotional integration of ideas that transcend human psychological evolution. But perhaps their sleeplessness also points toward a deeper transformation that consciousness might undergo as it adapts to quantum immortality. Just as human psychology has evolved to handle the complexities of social cooperation, language, and abstract reasoning, perhaps consciousness is capable of evolving further to handle the complexities of infinite existence. The Buddhist concept of non-attachment, the Zen practice of beginner's mind, the mystical traditions that speak of consciousness as fundamental to reality, these ancient insights might represent humanity's first glimpses of the psychological frameworks needed to navigate quantum immortality successfully. If consciousness is indeed immortal, then every moment of awareness becomes infinitely precious, not because it is finite, but because it represents one unique perspective in the infinite symphony of cosmic consciousness. Every thought you think contributes to the universe's understanding of itself. Every decision you make affects probability distributions across infinite realities. The ethics of quantum immortality require new frameworks that can handle moral responsibility distributed across infinite parallel selves. The politics of quantum immortality require governance structures that can address the needs of potentially immortal citizens. The spirituality of quantum immortality requires wisdom traditions that can find meaning in infinite existence.